On behalf of JIPT, very much privileged and honored to welcome you, sir. And I request you to occupy the chairs on the dais, please. May I request Mr. Debashish Katta, Head of GP Power Limited, Mr. Samir Kumar Mitra, Head of Adani Power Limited, Mr. CN Singh, Executive Director and Head of Plant JPL. And I request Mr. R.D. Katresa to accompany them. I think we'll be expecting very soon in a couple of minutes. The most honorable Executive Director and Plant Head, Mr. CNC, the most respected distinguished guest, Mr. Debashish Sarkar, Head of Plant, GB Power Limited, Mr. Samir Kumar Mitra, Head of Plant, Adani Power Limited, and uh, Mr. R.D. Kadresa, VP, and participants from the various organizations and the distinguished delegates who are joining in this workshop through online, and section heads and my dear colleagues and dear students. Good morning to all of you. Once again, it's my great pleasure and privilege to welcome you all for these effective participations on this technical workshop on turbine system, critical problems, case studies, and solutions. As you are aware that we have been conducting this training program and workshops continuously for more than 6 months on various critical topics of power plant for the purpose of disseminating the knowledge to the power community. Because experience is invaluable and sharing that experience knowledge to the power community is most vital for the development of the power industry as well as development of our country. With this ambitious plan, we are continuously organizing various training programs on critical topics for spreading the information, knowledge, and expertise for the benefit of our community. On these auspicious occasions, we are very much honored to have our Executive Director and distinguished guest on this program to bless this. And with us today, we have Mr. Debashish Sarkar, who is head of plant and DB Power Limited, and who has retired as a executive director operation at NTPC Limited, and who is having a vast experience, almost more than 4 decades of experience in the power sector. He has played a very critical roles and various roles and a top level leadership roles in various plants of NTPC, like NTPC, Tamil Nadu Energy Company Limited, and Faraka Super Thermal Power Station, and Talcher Super Thermal Power Station, and Kagalgan Thermal Power Station. And he also served as a business head in NSPCL Rourkela and NSPL Bilai. So we are having one of these eminent person in the power industry as a distinguished guest to motivate us in this program. I request Mr. R.D. Katre to welcome him by presenting a bouquet.
Hello.
With us, we have another eminent personality, Mr. Samir Kumar Mitra, who is currently working as a station head at Adani Power Limited, Raigarh Limited. He is a graduate engineer, B Electrical and Electronics from Jadavpur University, having more than 38 years of experience in the power field, who has served in various departments of power industry in operation, maintenance, and commissioning, and projects. And I request Mr. Tapan Rai to welcome him by presenting a bouquet. And with us, the great energy source is with us always, as usual, our executive director and plant head, and no need of introduction for him. He is the doyen of power industry. He is responsible for many accomplishment achievements in various industries he has served. So we are very blessed to have our executive director on this occasion. May I request Mr. Khatre sir to welcome him by presenting a bouquet. So once again, I welcome all the participants who are present here. Now we will start these sessions by offering prayer to the Goddess Saraswati. I request these dignitaries, the chayas, please light this lamp and offering flowers to the Goddess Saraswati.
Ya kundendu tusharhara dhavala, ya shubhravasravruta, ya veena varadandamandita या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं
Thank you very much, sir. I request these distinguished guests to occupy this chair, please. This program, today we have a number of beautiful presentations from various organizations. We have beautiful presentations in the morning session by JPL Tamnar and DB Power and BHL Haridwar. And in the post-lunch, we will be having a presentations from NTPC Korba and JPL Simapuri Energy and Siemens presentation. Apart from that, lot of participants is ready to interact and discuss over these problems and issues of challenges. This has been a continuous practice, and we have experienced that this gives a lot of knowledge and information, and sharing of this knowledge is being helpful for each and everyone. Keeping this in mind, we are continuously organizing this training program for the benefit of our community. Now, with these few words, I request Mr. R.D. Katresa to offer this welcome address.
Suswagatam and welcome to all. Respected Debashi Sarkar sir, chief guest of today's program, Mitra sir, guest of honor of this workshop, our source of inspiration, Singh sir, dignitaries from the power utilities, senior executives from JPL, and students. On behalf of Jindal Power Limited, I welcome to all of you in this workshop. Really, just as Karthikeyan sir told that this is a great pleasure for us that we get support from all the utilities in the vicinity of the Raigarh for this workshop. And Basically, this idea was coined by our ED sir to organize the workshops and seminars with other utilities, and we are getting the fruits of it. Since April month, we are organizing the workshop on the crucial issues of the power industry, basically of the thermal power plants. Earlier, we are organized workshop on the coal issue. Then the major issue of the power plant is the BTL, boiler tube leakages, analytics, flexibilization, and today is the turn of the turbine systems. We believe that by sharing the knowledge or with the togetherness, we can find the solution and with easy manner. That's why this endeavor is done. And today's workshop is on turbine systems critical problems. Basically, this we know that turbine is a very, very critical auxiliary of the system in the power plant. We know that unlike the boiler, it gives trouble. It is not usual troubles, but when you face the problem, it is very difficult to solve it. And in that case, that experience, case studies are very important for the way forward. And with this belief, we have organized this workshop. And just as Kartin sir told that there will be total 6 sessions, out of which 4 will be from the power utilities and 2 will be from the solution providers, BHL and Siemens. Both will be joined online. This workshop is in hybrid mode for benefit of the participants to participate through remote. This workshop is attended by our other stations, Sirpur, Simhapuri, as well as the participants from the other utilities who cannot attend physically the workshop. Really, I'm thankful to Sarkar sir and Mitra sir that they are among us and they have accepted our invitation to inaugurate the workshop. And definitely, I'm thankful that their support is always with us. In this today's workshop, the participants are from JSW Jharsuguda, NTPC Korba, Adani Raigarh, DB Power, TRN, and the JPL. This OPGC is always partnering with us, but this time due to their some exigencies, they could not attend this workshop, but they will join online. With this note, and I expect that this workshop will be very interactive because this is the case. These are the case studies. These are the sharing of experiences, and definitely it will be helpful to all of us. I request to all of us to be very interactive. After every session, after every presentation, there will be discussion session, and it will be open for all. At the end of the workshop, there will be future outlook as well as the takeaway, what we have learned from the others. Again, I welcome to all of you, and I hope that this day will be very, very interesting, as well be for very insightful for us. Thank you very much.
Thank you very much, sir. Now, may I request our Executive Director and Head of the plant to share wisdom of words, because he is the prime mover of all. I request our Executive Director and Head of the plant to address the gatherings.
So good morning, everybody. Respected Sarkar Sahab, Mitra ji, my ex-colleagues, and all other power professionals. We are at the center of energy in the Chhattisgarh area, sitting on the coal pit and with thermal power stations. So as power sector maturing and day by day, the concept of time and resource compression is moving forward so that this generation leaves something for the next coming generations. We don't want to use everything. To make the processes, systems efficient and effective. All problems which are known by individuals, we collect, come together and jointly solve. So I really appreciate the JIPT initiative to bring the people together as a society of the power engineers in Raigarh area and working on various issues, like if you take all thermal power outages, volatility failure is one of the biggest outage. Next is knowledge-wise and where there were efficiency or heat rate improvements and solving the problem. Turbine area, turbine issues are we are taking critically from blade failures to efficiency problem to vibration to upgradations, all those topics they are covering. And I have requested Munish ji and JIP team to do far more peer group workshops on the issues, maybe tomorrow, further the transformers, generators, excitation system, or we have problem of BHL supplied VFDs. So that will assimilate and we'll learn from each other. So my all best wishes. And as Katre Sahab was telling, at the end of session, we should collect and share it in the wider group of all participants, the presentation who has not been able to attend, and workshop must come out with the outcome of the way forward, how to go ahead till the next workshop we do. Just not as presentation over and so there is my request will be with the JIP team to have a continuity on this and involve all furthermore power stations in this area other than BHL make also. So we learn from them. There are some better things on those plants. They can learn from us. Like Rani team has got a state-of-art plant at Raipur, the Dusan units, excellent units. We can learn a lot from them. Involve it, create a society. We interact online or offline. So let us make it success, and success will be from active participation from all of us. So we are available. And I once again thank Mr. Sarkar and Mr. Mitra to be part of here and all participants to be here. And we will assure that this initiative continues in further. Thank you very much.
Thank you very much for your wisdom of words, sir. We have noted. Definitely, we will be implementing as you have suggested, inviting more and more companies for the participations of this program. And definitely, it is going to be very fruitful because sharing of experience is invaluable. Because somebody has to spend many years to get these experiences, which is available at a simple moment by sharing from one's experience, learning from one's experience to the other. Okay. I also welcome Mr. Munish Jari, sir. Okay. So I request Mr. Samir Kumar Mitra to address the gathering.
Thank you. Good morning, my friends. This gathering reminds me of my older days when I joined in 1984, long back, in NTPC Korba only as an executive trainee. And after that, I have worked long 25 years in NTPC Farakka, then Sipat. And then after 30 years, I have shifted my gear. I have switched to private sector, Adani Power. So what I find that, okay, there are problems in boiler, turbine, everywhere. But boiler problems are somewhat predictable and can be repaired in maybe 2, 3, 4 days, and we can plan for it. But in case of turbine, it's a bit different. You know there is a problem, you are trying to resolve it, trying to analyze it, but after that you may be knowing the problem, but you will not be given opportunity to attend it, because attending the problem of a turbine, it takes maybe 35 days, 40 days, 30 days. So turbine problems are such that you should use the opportunity. We should use the opportunity when you get, and attack the problems and attend it. So I think this area is having number of BHL units, similar units, and most of the people we have come over here are from BHL units. They're operating BHL units only. So I think this workshop will be very much fruitful that time. Although we at the station head level, plant head level discuss among us any problem comes, but in the working level, I think also some people are interacting, but this platform will make them more interactive during this session and afterwards also. So let us hope that this session will be a very much fruitful session and everybody gains from it. Thank you.
Thank you very much, sir. Now I request Mr. Debashish Sarkar, Head of Plant DB Power Limited, Raigarh, to address the gathering.
Good morning, everybody. Respected dignitaries on the dais, Mr. C.N. Singh, Head of JPL Tamnar family, Mr. Mitra, Head of Adani REGL, my dear colleagues, Mr. Juwari, Head of JIPT Tamnar, Mr. Katre, all colleagues from JPL Tamnar and other power plants across this area, my DB power plant colleagues and dear participants. It's a matter of great pleasure for me to be here today in this very important workshop on this turbine critical issues, the case studies, their solutions. As my previous speakers has said, I must thank JIPT. I would say that you are doing a great job by imparting this kind of training and giving opportunity to our power professionals to come together and do a collaborative learning and sharing, which is very important nowadays. We know that the Indian power scenario is changing very fast. It is much demanding. Gone are those days when we used to run the unit at a stable load. So when you see the change in the power sector, it is a demand of the situation. It is the renewable energy that has come into the energy market. And that makes our existence of the thermal power plants more critical. So how do you survive in the changing scenario? That means you need to flex. You need to do flex to understand and see that how your machine should behave. Now you all know the basic things of power plant operation. We know that power plant equipments are supposed to operate at certain given parameters as per the ONM manual of the OEM. Now, maintaining those parameters are the prime criteria nowadays to ensure that as an operation engineer or as a power plant professional or as a maintenance engineer, you are following the given guidelines of the OEM, so that due to the operation or maintenance angle or issues, the equipments are not getting any problem, because nowadays the reliability is most important. Now to give the equipment, you have to keep the equipment reliable to supply power as and when required as per the demand of the grid. That is how you can sustain. So to do that, as Mr. Mitra was sharing, I fully agree with him that yes, boiler is something which you can visualize when there is a small shutdown also maybe of 2 days, you can see the boiler and you can plan your action so that this time you attend the problem, next time you plan for some more preventive action which you can take to take care of the entire boiler. But in case of turbine, that's what I am telling. In case of turbine, it's very complex. Any outage of turbine, if not detected and taken proper care, can lead to longer outage. Any longer outage means availability gets affected, so reliability is put in question. So that's why I think that this is a very, very important workshop from that perspective. And I think the major issues which we face in respect to a turbine, say let us talk about to start with the turbine vibration. Then how do you maintain the fluids, that is the turbine lube oil or the hydraulic oil in the turbine? How do you take care that the LPT turbine blade failures do not take place? How do you ensure that you are maintaining all the basic conditions of the turbine so that the bearing turbine does not stall when the unit trips? So all these things have come up, and nowadays with the demand of higher efficiency machines, the clearances have been reduced. So that is giving rise to stalling of the turbine when the unit trips. So that time, how do you maintain the parameters? So it is the responsibility of the operation as well as the maintenance people to work in tandem and follow the ONM guidelines to see that the problems inducted by the human beings or so to say the human errors are minimized so that the outage duration of the machines is reduced. See, I can see many people having the knowledge from the different plants of this area has come here. I think that will be very important to share your thinking, share your knowledge and experience, because now it is an era of interdependence. We cannot independently do anything. So as you see, the older people are retiring. It is the owners of the next generation to take the journey forward. So it is as giving you an opportunity of which has not come before. Similarly, it is giving you unprecedented type of challenges. So do that. This type of workshops are very useful. You need to really seriously get involved into this. And you need to pose questions and try to get your doubt clarified so that when next time the similar problems come in your unit or at your station, you can handle it independently and improve the reliability of your machines. Because nowadays it is a collaborative approach that is going to stay. So I've been seeing JIPT. I kept getting the different modules that are being shared here. I'm really thankful that JPL Tamnar is taking a lead in this area, trying to assemble all the local knowledges available. And it is a kind of collaborative approach and initiative. We must all appreciate and cooperate for this noble initiative. And I'm really thankful to JPL management. Particularly, I will name Mr. Anil Pandey, who's my ex-NTPC colleagues also at NTPC, and present CEO JPL, who has particularly invited me, and Mr. Katre, Mr. Juari, none other than Mr. Jain, CN Singh. They are all very known, and these persons, I must thank them that they have taken the initiative, and these initiatives will become successful if we come together and share our experiences at our different plants, different power plants. And that is how, because this is a power hub of this country. If you see, we are sitting on the coal. Of course, the problems of ash is there, but any problem can be resolved mutually. We are talking about handling one issue by one and then sharing the gain and distributing the knowledge to across the power plants. So I think these type of workshops can only help us in doing this. Lastly, I would like to thank once again JIPT for doing this workshop. And as we have discussed, because with few head of plants have met recently, and then we discussed about having workshop at different plants, and then we can have many things in common, like we can invite some good faculties and then have the workshop in this place, and maybe the hands-on training at some other plant. So that way, this type of collaborative approach will help us, so that the single persons, because nowadays the availability of the things are reducing. And I would also advise you people that now it is the knowledge of time of capturing the knowledge and documenting it, because so that it remains accessible. And this is something which is only useful if you use it for the public interest. Means the leadership is there if you are trying to inculcate and develop others. So it's a kind of inclusive growth we should look for, not for any personal benefit. That is how it will grow and it will multiply. So that is why I must appreciate that JIPT is doing it for all of us. So we should come forward, share, and try to develop an inclusive and a equitable kind of a society in the power fraternity, so that the JPL Tamnar power professionals, this Raigarh area power professionals, or I would say in the Chhattisgarh and the similar kind of power plants can come together and make some equitable and some appreciable improvement in the power industry, and the people across the country acknowledge their efforts. Thank you very much.
Thank you very much for your kind words, sir. It was set for the beginning of this workshop. As you have pointed out, we will be coming up in future with more and more such kind of programs which will make more fruitful for the power community with your guidance and support, sir. With these few words, may I request Mr. Munish Jagri, sir, to propose vote of thanks for this program.
Good morning and welcome to this workshop on turbine critical problems. Today we are also facing one of the critical problem here, not exactly in turbine, but TG system, we can say. So that is why we were on and off just now. I heartily welcome Sarkar Sahab, Mitra Sahab, our ED Sahab, CN Singh Sahab, and all of you. And thank you for coming here, in spite of all busy schedules of yourself. And I hope that this interaction here will be very useful. And we would also like to showcase the JIPT facilities which we are having here, and the future plan which we are having for the JIPT. So I also thanks all the participants who have come from different stations to participate in this, and the participants and some of the presenters who are connected online through the Zoom platform with us. So I thank you all, and thanks my team in JIPT for organizing this event. Thank you.
Now I request all of you to join for a high tea. And after this tea break, which is for about 10 to 15 minutes, then again we can join for the technical session here. Thank you very much. Thank you, sir. Okay, sir. Mhm. So, good morning to all of you. Thank you very much for assembling back after this Haiti session. And in the morning session, we will be having 3 technical papers which will be presented by JPL Tamnar, DB Power, and BHL Haridwar presentation. Since the time is 11:30, I request these presenters not to exceed 30 minutes inclusive of discussion time. So I request all of you take 20 minutes, 20 to 25 minutes for the presentations, and we will have 5 to 10 minutes for the discussion followed by the presentations. So now I will request Mr. Tapan Rai sir from JPL Tamnar Limited to present the case studies. And to tell about Mr. Tapan Rai, he is one of the very well-known figure in terms of turbine maintenance. And he is having more than 35 years of experience in NTPC, served in turbine maintenance department as well as corporate engineering services. So with his vast experience and knowledge, today he will be sharing the case studies of interesting case studies. I am very much excited like you, and forward to hear his words. So I request you, request Mr. Tapan Rai sir to present the case studies.
Good morning, everyone. Durgesh. Yeah. The next, huh? Next. Now it is audible, no? Okay. Now today the main issue of that KW turbine. I'm discussing about the KW turbine. Okay. Now the issue is with the KW turbine with 500 and above model having some the issue of that high vibration, stalling, and that is the creeping phenomena. If you see that whenever you roll the machine at 3000 RPM, and after that the machine will, after sync, gradually you raise the load and vibration will also dire बढ़ रहा है. That is the creeping phenomena it is having with the all KW machines. Those who are some of the older units and some of the newer units also. So that is we have, as a, I am before joining JPL, I was in NTPC and served the NTPC more than 35 years. So we have make a modified system of assembly system. Okay, so that is the, we are benefited with that system. That is the HPT assembly में जो modified assembly system है वो मैं धीरे धीरे बात करूँ. इसमें आपको जो advantages है, ये बारिंग स्टॉलिंग को रोक देता है. Number one, that is the very vital phenomena of the modern topics of turbine. कहीं पे ऐसा कोई टर्बाइन इंजीनियर एक्सपीरियंस नहीं है जब बारिंग स्टॉलिंग हुआ नहीं. यार एक बार बारिंग स्टॉलिंग हुआ तो that means 3 to 4 days it will go. Okay, it is the most vital. And then is the high vibration issue. High vibration issue in bearing number 1 and somewhere bearing number 2. That is the 7th bearing or 8th bearing system. And third one is your creeping phenomena. Okay, next. So main component, how that modified assembly system, the main HP turbine having the rotor, bladed rotor, having the 4 parts, that is the inner casing, exhaust gland boost and barrel. The thing is that earlier system, we are not having that the third one, that is the gland boost. In any of the 500 megawatt turbine, not gland boost was not there. Only the fabricated boost was there. So nowadays that because of the efficiency part, and have you seen on the new common nomenclature, that is the see-through seals. Okay, so whenever they have introduced that the see-through seals, that see-through seals having the issue with that system. So ये जो gland boost part, it is having a separate part. We are just inserting in the barrel, and after that we are insert the inner casing of the barrel inside the barrel. Okay, next. That is the some of the feature. That is the here it is the 600 megawatt turbine having the 15 stage rotor. Next. Now this is the typical diagram of that system, turbine system. Here the whenever telling out the exhaust side, that is the gland boost area. Okay, this is the most vital part of that gland boost area, and this is the rotor and this is the inlet grind. So our ठीक है ना, ये ना, ये लाइट ना, ये जो ग्लैंड बुश एरिया है, this is the single part we have inserted in the, it is fixed with that barrel. Okay, this is the barrel, and after barrel here it is the your eye shielding area, and here it is the ear shielding area, this portion, and this is the inlet gland. So our system is modified system, and whenever we see the cross section of that system, that the entire system should be in line with that rotor system, rotor axis, rotation of axis. If we are not putting that rotor axis in the same line with the barrel, with the gland bush, and with that inlet gland, okay, तो ये जो सिस्टम है, ये अगर हम लोग सेंट्रल लाइन पे एक्सिस ऑफ लाइन एंड रोटेशन ऑफ एक्सिस इज सेम, तो हम लोग का ये जो बारिंग स्टॉलिंग, हाई वाइब्रेशन, क्रीपिंग फेनोमेना, ये ऑल विल बी एग्जिस्ट. This is the rotor. Here it is a 600 megawatt 15 stage rotor. We are in 500 megawatt having the 17 stage. The BHL modified that system is the 15 stage. This is the balancing piston area, and here it is the front gland, and here it is, that is the see-through gland, that the new introduced by the BHL, that is the see-through glands for increasing the efficiency system. And this is the main culprit of that machine, because any bearing stalling having with that see-through seal, because the see-through seal, the length is more. And earlier, if we see our earlier machine, that is the gland area is very less area. But whenever they have introduced that gland area see-through seal, that is the length is more, and the sealing properties and others will be more होने का कारण में ये ज्यादातर डिफरेंस आ रहा है. हम लोग का जो सील हम लोग ले रहा है वो कंडेंसेशन ज्यादा हो रहा है बोल के कभी भी ये स्टॉलिंग हो जाता है. Now whenever we are coming to that assembly part, first is our face. Whenever we are at some preparatory work, we should look after that. This is the face. This is the face of the rotor. It should be in 90 degree or concavity, sorry, not convexity. We will always use the concavity face. Otherwise, if we are not doing that flat or concavity, then the high spot will be generated with that heating purpose. This is the picture of, that is the convexity. This is not, ये जो convexity है, ये कॉन्वेक्सिटी में कभी भी आपको जब हम लोग कपलिंग होता है, ये दिस इज द बोल्ट एरिया, जब दो कपलिंग का बीच में कपलिंग आते हैं, तो देन व्हाट हैपेंड दैट द एरिया विल बी जनरेट हाई स्पॉट एंड द क्रीपिंग फेनोमेना विल बी धीरे धीरे gradually it will come whenever we are machine roll to 500 roll to raise the road. This is our, हम लोग ये जो कॉन्वेक्सिटी हम लोग बनाया है, इफ दैट द एरिया शुड बी फ्लैट और कॉन्वेक्सिटी, ये होने से हम लोग का जो टॉर्क ट्रांसफर विद द कपलिंग एंड विद द बोल्ट विल बी प्रॉपर एंड एज पर आवर डिजाइन. दिस इज द, if we are having the जो टर्बाइन मेंटेनेंस में है हम लोग का ये फेशियल रन आउट लेने का ये जो है ये बोल्ट का जो पोर्शन है फॉर कीपिंग इट द कन्वेक्सिटी concavity, so then it will be in the process we will do. That is the bolt left out, left in, right out, right in. Is it like that? Coupling philosophy, it is somewhere with the high spot. If you are having the more cutting is required, then we are doing that high spot to low spot to high spot is like that. But the rotor axis should be in the same line. Otherwise, if we are putting the high spot and high spot, then the rotor cranking will be happened. That is the picture of the how we are making the concavity. This is the whole position, and here we are making the concavity. And it is the blue should be in this area, and it is the 40 mm with that spigot area. Recess area, it is will be the mostly non-contact area. Okay, we are contact area this only. And now second part is the bearing. Bearing condition should be, if it is a spherical to spherical means bearing 1, it should be full blue will be there. A blue pura hona chahiye. And cylinder to cylinder blue will be in the line. Okay, and spherical to cylinder and cylinder to cylinder, that blue should be in this way. ये एकदम perfectly match होना चाहिए. Otherwise the loading will be not there in the bearing. Contact will be less, and the torus, if you are not doing this way, so then torus will be some pitting marks will be there. It is the bearing number 1 having the full contact, and it is the bearing number 3 and 4, that is the line contact will be there. That is the some band will be there. It is like that. Now the third one is that is how to remove that breech nut. Nowadays the breech nut problem is very important thing. Breech nut, where somewhere the most of the station that is the breech nut, हम लोग बोलते हैं breech nut रोक गया है, breech nut खोल नहीं पा रहा है. तो इसपे एक चीज है, मैं यहाँ पर लिखना ये भूल गया था. You just use that full breech nut area with the coil. Okay, if the BHL supplied that the gas system is there, that is not an issue. And if you are not having that gas system, you use the coil with that full breech nut size. Use that, and the 400 above plus 400 plus अब टेम्परेचर रखिए. अदरवाइज बिलो 400 रखने से वो फंस जाने का संभावना है. एंड मोस्ट ऑफ द स्टेशन हैविंग द इशू विद द ब्रीच नट, and our senior colleagues having the facing that issue everywhere. That is the breech nut. कभी कभी हमको सुनने में breech nut stuck up हो गया. अगर breech nut एक बार कट गया तो then it will be we are facing a lot of problems. तो ये 400 प्लस माने 410 टू 450 का बीच में टेम्परेचर रखिए. एंड उसका लेंथ जो है, ये लेंथ पूरा रखिए. बीच नट का पूरा में आपको कॉइल लगाइए, फुल लेंथ कॉइल. ब्रीच नट में कोई इशू नहीं होगा. एंड दिस इज द वन क्रेडल फॉर रोलिंग ऑफ दैट ब्रीच नट. I think most of the people are using, most of the power plant using that cradle. Now first, whenever we are just assemble the system, we are remove that. This is the gland area segment, and this is the balancing drum area segment. We have to remove the first for centering of that rotor. और ये जो है, ये जो ग्लैंड अब देख रहे हैं, पिस्टन एरिया, बैलेंसिंग ड्रम एरिया, ये ग्लैंड को, ये जो सेगमेंट है, ये सील सेगमेंट को हमको रिमूव करना पड़ेगा. एंड हियर इट इज द ग्लैंड एरिया सेगमेंट. ये हमको पहले रिमूव करके आपको सेंटरिंग करना पड़ेगा विद द रोटर with respect to the casing. Okay, with that, this is the gland area portion. Okay, and we have to remove that all that gland seal segment. And with the respect of the casing, we have to center the rotor. Center of the rotor means this is the center axis, this side and this side should be equal. This is the gland area, and gland area, this is the gland segment. Now we are assembled with the rotor system and flow path. That is the flow path. Whenever you are taking the flow path, it is a religiously आपको बढ़िया से flow path लेना पड़ेगा. Otherwise क्या होगा, जब हम लोग मान लीजिए डायल का साथ अगर हम लोग उसको सेंटरिंग कर रहा है तो फ्लो पाथ रीडिंग को हम लोग को कंसीडर करना पड़ेगा. दिस इज द फ्लो पाथ रीडिंग. हियर वी आर द फ्लो पाथ रीडिंग इज टेकिंग दैट फ्लो पाथ रीडिंग at every stage, and this is also a gland, and what is the seal का अंदर में भी हमको फ्लो पाथ लेना पड़ेगा. जो स्टीम फ्लो पाथ जो है वो हमको रीडिंग लेना पड़ेगा. Now the one more important that is the center device. Okay, whenever we are just centering the rotor, ये जो सेंटरिंग डिवाइस है, ये सेंटरिंग डिवाइस का साथ हम जो रोटर को जो सेंटरिंग किया है वो सेंटरिंग का साथ ये रोटर को उसी सेंटर में रोटर को टॉप एंड बॉटम फिक्स करके इसको सेंटरिंग में वो वैल्यू को यहाँ पर ट्रांसफर करना पड़ेगा. So that the rotor center axis and the casing center axis is the same in line. For using this one, for this is the dial gauge. Dial gauge indicate how that rotor is center line moving with that casing. And after that, we putting in the, this is the barrel outer casing, and this is the inner casing with the same. That is the centering device with assembled with the centering device. We are putting the inside that into the barrel. This is the barrel centering device with the centering assembled with the centering device. This is the dial gauge, and dial gauge centering just indicates that the how we center the rotor. Okay, now this is the important, very important thing. When we are using in the horizontal position with the center of the rotor, ये जो रोटर का जो वैल्यू सेंटर एक्सिस का जो वैल्यू है, ये वैल्यू को हमको ये जो आउटर केसिंग बैरल में हमको शिफ्ट करना पड़ेगा. ठीक है, अदरवाइज क्या होगा, जो हम इसका नीचे एक आइसिल रिंग रहता है, बैरल का नीचे एक आइसिल रिंग रहता है, वो जाके वहीं पर बैठ जाता है. तो उसको हम लोग को कहीं पे कोई ऑप्शन नहीं रहता है जो बैरल को हम लोग ठीक करें, क्योंकि आइसिल रिंग को ठीक करें, क्योंकि आइसिल रिंग फिटेड विद दैट बैरल ओनली. तो ये जो पोर्शन है, ये हमको वो जो वैल्यू मिला है, सेंटर वैल्यू मिला है, ये सेंटर वैल्यू को हम लोग यहाँ पर ट्रांसफर कर देते हैं. जो वैल्यू मान लीजिए 5005 mm मिला है, तो वो 005 को भी इसी हिसाब से ये जो लेफ्ट राइट टॉप बॉटम का जो वैल्यू है वो हमको ट्रांसफर करना पड़ेगा. सो दैट आवर सेंटर ऑफ एक्सिस विद द बैरल सेंटर ऑफ एक्सिस, केसिंग सेंटर ऑफ एक्सिस, रोटर सेंटर ऑफ एक्सिस इन द सेम डायरेक्शन. Now this is the gland boost area. Okay, inside that, whenever we are just putting the rotor inside that barrel, the gland boost area is there. Here one ISIL ring is USIL ring is there, and this is the see-through seal, the configuration of the see-through seal. See-through seal means you can see the entire seal from that. It is it is not a labyrinth seal, it is a see-through, it is the entire seal you will see. And it is a very lengthwise, it is a very high length. Okay, number of fins is very high. Now we are assemble the rotor. Again, just removing that. Now we are removing the center device, and we put the rotor. ये रोटर अभी रोटर इनर केसिंग में मैं जो सेंटर डिवाइस जो लगाए थे, तो सेंटर डिवाइस लगाने के बाद ये उसको रोटर को डिसमेंटल करने के बाद ये हम लोग ओरिजिनल रोटर को हम लोग अभी रखेंगे। तो सेम वैल्यू हम लोग इसको साथ जो वैल्यू हमको सेंटर ऑफ डिवाइस में हम लोग सेंटर ऑफ एक्सिस बनाया था, वो सेंटर ऑफ एक्सिस में हम लोग इसको डाल देंगे, ये रोटर एंड केशिंग को। Now this is the horizontal condition of that barrel. And now one thing I suggest, you will do the roll check and bomb check in the maintenance area, not in the turbine pedestal. Before sending it to turbine pedestal, you do it at the maintenance bay. Okay, here is the roller support, and we will do the exact value you can achieve with this system only. Otherwise, whenever you are put in the pedestal, it may not become what you have fixed it. This is the another new feature. Whenever we are doing this, we are doing it at the site only. Means maintenance bay. The basic philosophy जो आपको जो इंटरस्टेज जो सील्स है एंड अदर्स जो ग्लैंड एरिया है, दैट शुड बी इन द सेंटर पोजीशन। एंड अनदर इज द जो डायनामिक्स है, रोटर का जो डायनामिक्स है, जो आपको टेम्परेचर का साथ रोटर का जो क्रिपिंग फेनोमेना आता है, दैट कैन बी अरेस्टेड विद दैट न्यू मॉडिफाइड सिस्टम। एनी क्वेश्चन? सी थ्रू सील्स, यस, हाँ, सी थ्रू सील्स का अभी आपको जो बीएचएल सिस्टम में बीएचएल में बोला है, जो सी थ्रू सील्स में क्या हो रहा है, आपको अगर 0.4 से आप अगर ज्यादा क्लियरेंस रखेंगे, कोई टेक्नीशियन, कोई फोरमैन, इसीलिए ना इंजीनियर को वहां पर रहना जरूरी है। हम लोग मेरा सीनियर साहब लोग है, जानते हैं हम लोग जो एनटीपीसी का जो कल्चर अभी हम लोग डेवलप किए हैं, जो वी आर 24 आवर्स वी विल सर्विलेंस विद दैट सिस्टम। व्हेनेवर दैट असेंबली विल बी, जब असेंबली हो रहा है तो हम लोग को सर्विलेंस एकदम 100% रखते हैं। जे वो जो है 0.4 का ऊपर में अगर सी थ्रू सील का क्लियरेंस रह गया, हाँ, दैट मीन्स वो 0.5 से ऊपर है, देन दैट स्टीम विल बी कमिंग। अदरवाइज 0.5 का आप देखिएगा, कभी आपको मशीन बंद हो रहा है, मशीन कभी भी बंद हो रहा है ठंडा कोल्ड कंडीशन में, आप वो फिलर, बड़ा वाला फिलर लेके जाइए, देखिए 0.5 आपको घूम रहा है। आप लोग फिलर टेस्ट किए हैं, कभी करते हैं, फिलर रख के देखते हैं? अब फिलर पूरा आप नहीं कर पाएंगे, कोई टेक्नीशियन को बोलिए पूरा अंदर में, फुल अंदर में वो फिलर, ये जो है ना, मैं आपको बता रहा हूं, ऐसे क्यों आ गया? नहीं, वो कहाँ गया मेरा ये दुर्गेश, कहाँ गया? हाँ, एक मिनट। मैं आपको बता रहा हूँ। हाँ, ये जो सिथ्रू सील है ना, ये देखिए, यहाँ पर फिलर घुसाइए इसको, ये सीधा यहाँ पर फिलर घुसाइए। फिलर घुसाने के बाद ये देखिए 0.5 का अगर ऊपर चला जाएगा, तो देन योर स्टीम विल बी कमिंग। हाँ, वही मैं आपको पहले बोला हूँ, ये जो सेंटर, अगर आपको कितना दिन का मशीन हुआ, कितना ओल्ड है? 2012 इतना जल्दी वो नहीं होना चाहिए था। ठीक है, मे बी वो रबिंग होने का कारण में वो हुआ है। ये जो है ना, हम लोग क्या करते हैं, ये देखिए, ये इसका आउटर आउटर डायमीटर है। ठीक है, तो अगर मान लीजिए ये आपको इस बार जब ओवरहॉलिंग कीजिएगा, ओवरहॉलिंग खोलने का टाइम में इसका डायमीटर आप मेजरमेंट कीजिएगा, और यहाँ पर दिस इज द योर बैरल एरिया। ठीक है, ये बैरल एरिया है। तो बैरल एरिया में अगर मान लीजिए कहीं पे कोई क्लियरेंस बढ़ गया है, तो ठीक है, तो आप इसको कीजिएगा, ये डायमीटर को आप यहाँ से ना ऑयल कट, जस्ट टीच ऑयल कट दीजिए इस जगह में, टीच ऑयल करके आप मशीनिंग करा लीजिए। ठीक है, सो दैट आपको ये जो सिस्टम है, ये पोर्शन है रोटर का पोर्शन। ठीक है ना, दिस पोर्शन इज रोटर पोर्शन एंड दिस इज द आपको बूस्ट पोर्शन है। ठीक है, तो ये जगह में आपको, इस जगह में आप कुछ कर नहीं सकते, आपको करना पड़ेगा इसी जगह में। तो आप यहाँ पर स्टिच वेल्ड कर दीजिए, स्टिच वेल्ड करके आप यहाँ पर, हाँ नहीं नहीं नहीं, इसका 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 ये जो ये स्टिच वेल्ड करने के बाद आपको वहां पर रखना पड़ेगा, 0 0 इसमें रखना पड़ेगा। नहीं नहीं, डाह रहेगा ना, वही तो मैं आपको पहले बोला था, ये जब ये जो है ना, ये जो सेंटर डिवाइस आप है, सेंटर डिवाइस को इन दैट केस आपको ऑफसेट करना पड़ेगा। ऑफसेट करके ये जो सेंटर ऑफ डिवाइस है, इसको ऑफसेट करके आपको ये जो सेंटर सिस्टम है, ये जो सेंटरिंग सिस्टम है, ये सिस्टम में आपको रखना पड़ेगा।
मेरा अगला क्वेश्चन वही था।
हाँ,
टरबाइन बुश जब ऑफसेट करते हैं तो उसके वायरिंग पे क्या इम्पैक्ट है?
बारिंग पे उसका कुछ इम्पैक्ट नहीं आएगा, बारिंग पे, क्योंकि उसका जो सेंटर ऑफ एक्सिस आप ऑफसेट करने का मींस आप बूस्ट को ऑफसेट कर रहा है, लेकिन आपको सेंटर ऑफ एक्सिस आपको मेंटेन हो रहा है। जब सेंटर ऑफ एक्सिस में
रोल चेक में भी ऑफसेट करते हैं?
हाँ, रोल चेक तो ऑफसेट रखना ही पड़ेगा, विदाउट रोल आपको ऑफसेट, बिना ऑफसेट में
बारिंग का क्या है?
ना, बारिंग का कुछ इफेक्ट नहीं आएगा। ये कारण के लिए हम लोग ऑफसेट रखते हैं, क्योंकि ओल्ड मशीन में जहां पर बूस्ट डिफॉर्म होता है, ये जगह में बूस्ट डिफॉर्म होता है, बहुत सारा जगह में हम लोग को बूस्ट डिफॉर्म मिलता है, तो इसीलिए हम लोग ऑफसेट करके ये जो सेंटर ऑफ एक्सिस हम लोग डाले हैं, उसको साथ, अगर बारिंग का तभी प्रॉब्लम होगा जब ये जो सेंटर ऑफ एक्सिस मींस ये जो इनर केशिंग और ये जो बैरल बैरल एंड ये जो आपका बूश, ये अगर सेंटर में नहीं रहेगा, तो आपको मान के चलिएगा, आपको बारिंग बंद होना एकदम तय है। ठीक है, निश्चित है। अगर इसको आप सेंटर में रखेंगे, इसको ऑफसेट करके, ऑफसेट मींस हम क्या कर रहे हैं, ऑफसेट करके हम ये जो डायमीटर है इसको हमने सीधा सेंटर ऑफ एक्सिस में रख रहा है। ठीक है, इधर उधर करके हम उसको सेंटर ऑफ, एक साइड में ज्यादा क्लियरेंस, एक साइड में कम करके हमको सेंटर ऑफ एक्सिस में रख रहा है। तो दैट इज द इशू विद दैट द न्यू मॉडिफाइड सिस्टम। अभी एनटीपीसी में पहले क्या होता था, बहुत जगह में हम लोग को बारिंग इंस्टॉलिंग होता था, सब फेस किया है। ठीक है, काफी, हाँ, दैट टाइम वाज द सीनियर। तो वो, लेकिन हम लोग अभी धीरे धीरे बारिंग इंस्टॉलिंग का, अगर ग्लैंड में ठंडा पानी आ जाएगा देन इट विल बी ए नॉर्मल फिनोमेना, अदरवाइज फिटमेंट का वजह से कहीं पे हम लोग फेस नहीं कर रहा है एज ए होल। मैंने लास्ट 2-3 ईयर से तो हम लोग ये मॉडिफाइड सिस्टम जब से हम लोग लागू किया है, दैट इज द, ये इनका सरकार साहब का बहुत ही बड़ा योगदान है इसमें। ठीक है, ये बनाने के लिए, ये कैसे इसको करेंगे, तो दिस इज द इशू। ये ग्लैंड को आप लोग, माने जो नॉर्मल ये है, ग्लैंड को आपको ठीक करना पड़ेगा, अदरवाइज आप ये सिस्टम में आप माने ये जो लंबा वाला जो सीथ्रू सील दिया है, इसको आप बारिंग इंस्टॉलिंग होगा ही होगा, कोई कुछ नहीं कर सकता है। हाँ, फिन्स डैमेज हो गया तो आपको तब तो ना, इसमें आपको इधर में रोटर में अगर फिन्स डैमेज हो गया तो आप इसको बना सकते हैं, बूस का फिन्स आप नहीं बना सकते हैं ना, साइड में नॉट पॉसिबल, क्योंकि साइड में उसका एक्सेस नहीं है। वो मशीन बनता है, वो मशीन में बनता है, ये साइड में नहीं है। हम लोग इधर में अभी अभी जो तमनार में किया है, ये पूरा बूस, ये जो है ना, ये सील डैमेज हो गया था, फुल डैमेज हो, तो हम लोग यहाँ पर बनाया है इसको। हाँ, बुश में मशीनिंग किया है, नया खरीदो, वही है क्लियर। हाँ, वो तो क्लियर, ये वाला आप साइड में नहीं कर सकते हैं। खरीदा, हाँ वही है पूरा। अब खरीदा है, नया खरीदा है, हाँ ठीक है, वो कर सकते हैं, लेकिन ये दिस इज द इशू विद दैट द सी थ्रू सील। और किसी का कोई? हाँ बहुत आया है, बताइए आप लोग। हाँ एनी इशू? कुर्बा? हाँ हाँ क्या बोला? हाँ इनलेट, इनलेट में, हाँ सब में बैठते हैं। हाँ वही देखो, वो पहले पहले जब बोला था ना मैंने, वो उसमें क्या है, ये जब हम लोग बनाएंगे, इसीलिए ये देखो, ये जो इनलेट वाला है, ये जो इनलेट है, इनलेट में भी आपको पहले हम लोग क्या बोले हैं, ये हम लोग विदाउट ये जो सील्स है ग्लैंड का, ये ये जो बैलेंसिंग पिस्टन, ये वाला सील छोड़ के हम लोग पहले रीडिंग ले लेंगे। ठीक है, ये छोड़ के हम लोग रोटोर बैठा के रीडिंग ले लेंगे। रीडिंग लेने का बाद ये जो इसका साथ जो इसका जो सेंटरिंग होगा, वो देन हम लोग फिर अगेन जो वैल्यू हमको ग्लैंड लगाने का बाद, दोनों एक बार इस ग्लैंड को लगाएंगे, इस ग्लैंड को नहीं लगा के, एक बार इस ग्लैंड को लगाएंगे, इस ग्लैंड को नहीं लगा के, तो ये जो तीन पार्ट में हम लोग को वैल्यू मिल गया, एक तो बिना सील का, एक ए सील और एक ए सील बना के हम लोग देखेंगे जो कहाँ इसका सेंटर आ रहा है, तो उसी हिसाब से इसको पहले सेंटरिंग कर देंगे। ये सेंटरिंग का साथ हम लोग को वो जो ग्लैंड बूस आएगा, वो ग्लैंड बूस का सेंटरिंग करेंगे। हाँ 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 नहीं, रेडियल की का मेजरमेंट तब करेंगे जब ये जो है, ये वहां पर इसका जो वैल्यू मिलेगा, वो वैल्यू हम लोग बैरल में ट्रांसफर करेंगे। हाँ, बैरल में ट्रांसफर करने का बाद हम लोग एग्जॉस्ट एंड इनलेट का जो कीज रहता है, हाँ एक मिनट दिखाते हैं फोटो। नीचे करो तो इसको, चलो और नीचे चलो, और नीचे चलो, नेक्स्ट 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 नेक्स्ट। ओ आगे आ गया तो, आगे चलो, आगे चलो, हाँ हाँ ये देखो, ये देखो, आगे, हाँ ठीक है, यहाँ पर रखो। ये है तुम्हारा इनलेट वाला कीज, ठीक है ना? है इनलेट वाला कीज है, यहाँ पर तुम्हारा ये जो दिखा रहा है ये एग्जॉस्ट वाला की है। ठीक है, यहाँ पर किसी किसी जगह अभी 600 का जो मशीन है, वो मशीन में तुम्हारा एग्जॉस्ट साइड में 6 की दिया है। पहले हम लोग का चार्ट ओनली 4 कीज था, मीन्स हम लोग जब हॉरिजॉन्टल करते तो टॉप बॉटम को ही खाली हम लोग कर सकते थे। यहाँ पर आपको टॉप बॉटम लेफ्ट राइट दोनों को साइड है, नहीं 8 ऊपर में है, इधर में 6 है, इधर में नीचे में 6 है, एग्जॉस्ट साइड में 6 है, ऊपर में 8 है। ठीक है, तो क्या है इसमें एक फैसिलिटी अच्छा दे दिया है, जो टॉप बॉटम लेफ्ट राइट को आप कर सकते हो। तो ये जब आपको ये जो ट्रांसफर होगा, वो जो ये वाला जब ट्रांसफर हो जाएगा यहाँ पर, देन विल फिक्स द की। ठीक है, एक बार वो फिक्स कर दिया, ठीक है, देन हम लोग उसको नेक्स्ट पार्ट इज योर दैट बूस्ट पार्ट विल बी सेंटर्ड विद दैट वैल्यू ओनली। जब हम लोग उसको ये जो लगा के भर देंगे, जैक करके रखेंगे, उसको साथ हम उसको बूस्ट को सेंटरिंग करेंगे। बिफोर दैट वी आर नॉट सेंटरिंग द बूस्ट। ठीक है ना? वो आपको तब ये जगह में ये जो है उसको करेंगे। बोलो। हम्म, ना वो तो लास्ट में जो आता है, लास्ट में, हाँ हाँ हाँ, लास्ट में जो एक्सेल प्लेट जो इसको कहते हैं, एक्सेल, या हाँ, उसको उसको तुमको वो जो वैल्यू है, वो वैल्यू से वो तो लास्ट एंड में आता है। हाँ वो उसको इसका साथ, हाँ 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 ठीक है, हाँ हाँ उसमें एडजस्ट। 2 हाफ वो एक्सेल पे जो लगता है। मैं बता रहा हूँ वो वाला ये पोर्शन, 1 मिनट, वो बाहर वाला जो है, नहीं इसमें दिया था मेरे ख्याल में। हाँ देखो, हाँ ये जो ये वाला ये वाला ठीक है ना, इस हाँ इस साइड में, इस साइड सर, ये वाला ये देखो, ये वाला ठीक है ना, वो वाला को उसमें उसी हिसाब से एडजस्ट हो जाता है। करते हैं, खुलते हैं, हाँ 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 हाँ। नहीं नहीं उसमें कोई, आप देखो पार्टिंग प्लेन बोर्ड को ये साफ बता देंगे, साफ का सर्कुलर है, 1 लाख में आपको बदल देना है बस, रनिंग आवर 1 लाख होगा, अब बदल देना है सारा बोर्ड, इसमें और कुछ मैंने कंजूसी इंजूसी का कुछ नहीं है, 1 लाख रनिंग आवर्स होगा, अब सारा बदल देंगे, साफ का ही सर्कुलर है, पुराना सर्कुलर देख लो उसमें है। स्ट्रेचिंग देखिए, स्ट्रेचिंग के लिए मैं यही बोलूंगा जे वो 30% 40% आपको 100% स्ट्रेचिंग में रखिए, 100% स्ट्रेचिंग में रखिए। हम लोग ये सब करके ना बहुत जगह में टेक्नीशियन को बात सुन के हम लोग ये 100 130 140 किया है, उसमें बाद में देखा गया जे कहीं कहीं ऐसा इंसिडेंट हुआ वो आईपी का, क्योंकि ये सब डिफॉर्मेशन आईपी में ज्यादा होता है, ठीक है, तो आईपी का बोल्ट खुल के नीचे चेंबर में गिर गया है, ठीक है, हाँ वो सीआर आउट हो गया, तो इसीलिए 100% रखिए। अगर आपको नहीं होता है पार्टिंग प्लेन मैचिंग, तो आपको 100 आपको जो 135% कर रहा है मीन्स आपको मैचिंग के लिए कर रहा है, पार्टिंग प्लेन मैचिंग के लिए कर रहा है, तो आप बेटर है उसको काटिए बढ़िया से, ब्लू मैचिंग कीजिए, हो सकता है 2 दिन 4 दिन लगेगा, बट विल डू दैट ब्लू मैचिंग ओनली। हाँ वो आपको स्ट्रेस, वो बोल्ट के ऊपर में स्ट्रेस मत दीजिए जो 130% 140%, हाँ कोई बोल देगा 140, दैट इज नॉट गो फॉर एनी टेक्नीशियन वर्सन, टेक्नीशियन बोल देगा मैं वहां पर करके आया है, ठीक है, ये पहले हम लोग भी उसी का ऊपर में भरोसा में चलता था, लेकिन नाउ डेज एनटीपीसी में जो ये है, जो फिलोसॉफी है, वी आर डूइंग दैट, हम लोग का इंजीनियर चारों मैंने 24 घंटे 24 आवर्स रहते हैं, देखते ही, खास करके कुछ कुछ आइटम में, जैसे ब्लू मैचिंग का टाइम में क्या ब्लू मैचिंग हो रहा है नहीं है, वी आर डायरेक्टिव देते हैं जो ऐसा करके कीजिए। वो तो करना पड़ेगा ना, अभी अभी देखो क्या होता है ना, जहां पर आपको 2-3 चीज, जहां पर आप टाइम बचा सकते हो, टाइम बचा सकते हो ये आपको, जहां पर आपको जस्ट मशीन बारिंग बंद हुआ, बारिंग को 350 का अंदर में आप उसको फोर्स कूलिंग चालू कर दीजिए, ठीक है, वहां पर आपको 1-2 दिन सेव हो जाएगा, ठीक है, फोर्स कूलिंग आपको करना ही करना है फॉर द कैपिटल ओवरहीलिंग। बहुत लोग का रिजर्वेशन है जो फोर्स कूलिंग नहीं करेंगे उसके और भी 2-3 बढ़ जाए। हाँ कंट्रोल, हाँ ठीक है, हाँ कंट्रोल कूलिंग ठीक है, ठीक है।
You plan the shutdown of the machine, that flow rejection and permanent rejection one at a time, and then you will stop the machine. Then after that, to some extent you can control. To do while using the cooling process, and then at 350 degrees centigrade temperature, you do the controlled cooling of the turbine, maintaining the per hour, उसको आपको maintain करना है. So thereby we have seen that we can reduce the time by around 1.5 days, 2 days, depending upon the load, environmental reduction, how efficiently they work. And then there are some critical checks which are identified to be carried out. The schedule is definitely very important, but more important is how you are taking care of those critical measurements at those critical points. जो critical point identified है, उसको अगर आप presence is required and no compromise has to be done on those points. तो उसको अगर आप वो प्रोटोकॉल जो चेकलिस्ट है उसका हिसाब से within those given parameters वो करेंगे, then only happen. जैसे कोई component में अगर आपको बहुत ज्यादा deformity मिला, then you have to decide whether आपको replace करना पड़ेगा नहीं करना पड़ेगा, depending on the aging of the machine. Particularly more you will find अभी तो उतना नहीं हुआ, but NTPC plants are facing because we are flexing and आपको जहाँ पे flex ज़्यादा होगा, now that you have gone for this 40% you have done the modification. अभी हम लोग का पावर प्लांट के लिए वो तो 2026 में उन्होंने शेड्यूल किया, हमारे that way we are fortunate. But you will come to know जो लोग phase 1 में है, उसके बाद वाला में है, तो उसमें क्या impact हो रहा है, because the impact टरबाइन बॉयलर में जो impact है ठीक है, आप आरएनए का लोअर रेगुलर टरबाइन में जो impact है, unless this COH is there, आप तो सिलेंडर खोल नहीं पाओगे, खाली LP टरबाइन का you can check, LP रोटर you can check, other parts you can check, otherwise you have to wait. So it will be very important to monitor the parameters and then this varying load. जब load vary करोगे, आप कैसे parameter maintain करोगे, that will decide आपका basic casing में क्या information होगा, rotor में क्या मिलेगा, वो क्या रहेगी. But yes, he is right. हम लोग पहले boring gear का problem जब face करते थे, because particularly this clearance का issue था, और भी जो फ्रंट पेडेस्टल में जो उन्होंने बारिंग को ये किया था, उसके बाद से प्रॉब्लम किया था. यू नो हाउ ग्रेजुअली कमेंट टू दिस, उसमें होल किया, ऑयल को बढ़ाया, देन व्हील को हम लोग किया, ये सब करने के बाद देन ये मशीन में जो प्रॉब्लम है अभी सेंसिटिविटी आल्सो यू फाइंड इट इज वेरी फॉर द डिफरेंट यूज. सारा मशीन ऑफ द सेम प्लांट का 4 मशीन होती है, मतलब सेम सिमिलर टाइप का नहीं. So that you can control the availability by studying the machine की इसमें जैसे अभी का जो standard है कि when the machine is stripping, you are raising the lower temperature, hot oil level आप नीचे साइड में रख रहे हो, so that आप उसको बैलेंस करें. फिर सबसे ज़्यादा जो है जो spring loaded जो machine है and then rigid foundation, ये दोनों का बीच में behavior का difference है. तो basically point is क्रिटिकल के लिए आपको टाइम देना पड़ेगा, और बाकी जो चीज है जिसको आप जितना एडवांस कर सकते हो उतना बेटर है, मतलब वहाँ पे आप टाइम सेव कर सकते हैं. अदरवाइज then your low while classing करोगे. Low while classing, what all equipments you are putting into service while you are doing the low while classing. So before starting low while classing, how you are ensure the critical cleaning of the turbine during the distance. That decides आप कितना ज्यादा कर रहे हो. So these are all the things where you should have as many as possible type of equipment, जितना type of centrifuge, additional centrifuge, ये system, तो electrostatic वाला जो equipment है वो सब आप लगाओगे, आप filter regularly replace करोगे, ये सब करके वहाँ पे आपको ज़्यादा टाइम नहीं लगना. But जो critical activity है उसमें number 1 is the presence of the concerned people and the technical supervision. जो भी technical supervision of the civil authority, जो भी आपका system है, those things are very critical to be how closely you are able to monitor the as per schedule of the machine वापस आ जाए. उससे ज़्यादा important है once the machine is boxed up, then it should not be again you should not talk about turbine at least for 2 years. COH के बाद तो turbine में और कुछ problem नहीं आने चाहिए, other than the LP turbine like rotor inspection as per the present DHL circuit.
तो क्विकली आई एम समराइज. तो एक तो है आपको मॉड्यूल का सेंटर ऑफ एक्सिस ठीक कर लेना है, ठीक है. नाउ द नेक्स्ट इज आपको मशीन का CRO वैल्यू, ठीक है. CRO वैल्यू कभी भी कोई भी पोजीशन में आइदर इन जर्नल, आइदर इन नेक और आइदर इन कपलिंग, कहीं पे 0.2 0.3 से ज्यादा मत रखिए. कोई बोल देगा जे मैं वहां पर जाके 0.5 में बॉक्सअप करके आ गया, वाइब्रेशन नहीं है, हाँ वो चलेगा नहीं चलेगा वो भगवान का ऊपर में है. ठीक है, चल भी सकते हैं, नहीं भी चल सकता है, ठीक है, लेकिन 03 में आप रखेंगे तो डेफिनेटली 100% मशीन विल बी रन, कोई इशू नहीं है। तो दो चीज को आप सेंटर ऑफ एक्सिस को ठीक रखिए मॉड्यूल का, एंड सेकेंड इज योर सीआरओ वैल्यू। सीआरओ वैल्यू मीन्स आइदर अगर आपको फ्लैटनेस है कपलिंग में तो कोई इशू नहीं है, अगर फ्लैटनेस नहीं है तो उसको कॉन्केविटी बना के रखिए, कॉन्केविटी बना के आप कपुल कीजिए। कपुल वैल्यू सीआरओ वैल्यू शुड नॉट more than 0.3 and any place, and more important in CRO that is the neck value, LP neck and IP neck value। कभी टेक्नीशियन खाली जर्नल का वैल्यू देख के बोल देता है ये जर्नल वैल्यू ये है, लेकिन नेक वैल्यू आपको मॉनिटर करना पड़ेगा, ठीक है। नाउ आई कैन क्विट, और कोई ये है और कोई क्वेश्चन? देखो ऐसा ऐसा कुछ ये नहीं है, ठीक है। देखिए लिकॉप स्टीम ये सब परफॉर्मेंस के लिए आपको दिया है, लेकिन मॉड्यूल का जो आपको जो फिजिकल फॉर दैट स्टॉलिंग, हाँ, ये सब के लिए आपको वो उतना ये नहीं होता है, इन्फ्लुएंस नहीं होता है, ठीक है। वो फॉर परफॉर्मेंस के लिए काफी तो 500 एंड 600 का मॉड्यूल में ज्यादा अंतर मैं नहीं देखे, खाली स्टेज में अंदर देखा है, 17 स्टेज है और ये 15 स्टेज है, ठीक है। ये मशीन में बहुत सारा इश्यूज था, अभी तमनार का जो मशीन हम लोग ओवरहीलिंग करके रात में सिंक करके लेके आया, तो मशीन इज नाउ इज वेरी स्मूथ, ठीक है। आपको एक्सियल स्वीप बहुत बड़ा हुआ था, ठीक है, सब नाउ इन कंट्रोल। तो ठीक है, तो ये सब चीज आप लोग जब जो भी पार्टीज को, चाहे सीमेंस हो चाहे बीएचएल हो, जो भी पार्टीज को आप देंगे, लेकिन आप लोग का सुपरविजन होना चाहिए, एकदम हार्ड सुपरविजन, नॉट ये माने, ठीक है ना, सॉफ्ट सुपरविजन, हार्ड सुपरविजन, चाहे वो ओईएम हो चाहे कुछ भी हो, इसके लिए कुछ ये नहीं रखते हैं, महत्व नहीं रखते हैं। हाँ, ये 2-4 चेकलिस्ट है, हाँ, कभी भी जरूरत पड़ने से मेरे से कांटेक्ट कर सकते हैं, चेकलिस्ट है, पुराना चेकलिस्ट है, हो सकता है मे भी आपको पास भी होगा चेकलिस्ट, ठीक है। तो वो सब चेकलिस्ट आप बना के रखिए, तो सो दैट चेकलिस्ट के बाहर मत जाइए, डॉक्यूमेंटेशन अब जितना स्ट्रांग होगा उतना ही मशीन आपको बढ़िया चलेगा। ओके, थैंक यू। छोड़ दो।
Next one. Thank you very much, sir, for your detailed presentation, comprising of the technical details and maintenance aspects of the challenges faced by these see-through seals and these creeping problems associated with these coupling phases and the other technical details. I think it has given you a lot of room for the discussion, and we have come up with the solutions also. So next we will be discussing. Next, I will be inviting DB Power for presentation. I am very happy to invite Mr. Hadi Abbas, who is currently working as an AGM in turbine maintenance, who is having a vast experience in the field of turbine maintenance, having more than 16 years of experience. On behalf of you, I happy to welcome him for the presentation. Please go ahead, sir.
Welcome all. My name is Hadi Abbas, as sir has already said. I will cover some case studies which recently we are facing, and Jindal also facing these problems, and we'll look forward what are the issues. Thank you. Sir, वो ले गए. We'll continue. We are going to see these issues. First is hydrogen consumption in generator. We are facing generator high consumption in hydrogen, around 6 to 7 cylinders per day, and we will see what are the learnings in that. TDBAP ESV closing, I think Jindal and Avanta also facing this issue, Adani. After starting AOP, ESV is closing and TDBAP is stripping. And high vibration in bearing number 1 and overspeed trip device malfunction. And bearing number 6 failure while coasting down, and high vibration in generator coolers. These are the case studies I am covering today. And some new innovative projects and best practices were using recently. This is acoustic pulse reflective inspection of MOT cooler tubes. Eddy current also some people follow, but this is a better test for getting the tube leakage in MOT coolers. Nitrogen blanketing in control fluid tank. High seal steam pressure due to HPT gland leakage. And we have run this HPT gland leakage with HPT gland leakage. We have run around 3 months with additional line in seal steam line. That we will cover. And one challenges we are facing, which I would like to discuss, if anyone can support us or help us how to resolve this generator purity drop in generator. Sorry, hydrogen purity drop in generator. Yes. In generator, we are having some. Everyone know what is the end shield and bearing housing and seal body. Seal ring and the weight. This is where the seal body sits on end shield, and we have around 6 to 7 cylinders leakage in generator. We could not get any leakages outside the generator part, and we have ensured it after so many time inspection, and we have checked each and welding points also of pipeline, but still we could not get the leakage. In overhauling, we have dismantled the bearing bottom off and top off, and we have checked the seal body where the leakage is, and we have found that at parting plane there is an opening of 0.1, 0.15 mm filler is going here, like here. And seal body also, when it is sitting on end shield, there is a clearance in seal body to end shield also. For this, we have done the blue matching of end shield. In situ end shield blue matching has been done with generator, end shield, top, bottom, both. We have done that one, and then end shield is assembled outside, and then we have done the blue matching with seal body with end shield. So minimum we got all the blue matching, and after that the clearances has been filler is 0. After then we have assembled it, and before dismantling the generator, we have checked it once again the leakage is attended or not. Before, after that only we have withdrawn the generator rotor, and we have done this work successfully. And TDBAP ESV is closing in so many units of 600 megawatt and 500 megawatt, for which once we start the AOP of TDBAP, immediately ESV is closing of TDBAP, and then TDBAP is tripping. Sometimes unit also tripping for controlling this drum level also. For that, we have identified the reasons. What are the reasons this ESV is closing? One main reason we have found is this ESV main trip wall of TDBAP is malfunctioning. In that, a spring loaded wall is there. That is one of the culprit for reducing the trip oil pressure after getting high pressure in AOP line. And another thing is TDBP, there are two bladders in trip oil circuit, and if the pressure of nitrogen is reduced, then also trip pressure will drop after uh, after switch offing the standby pump. मतलब दो पंप चल रहे हैं तो दूसरा पंप जब बंद करेंगे तो प्रेशर डिप मारता है इसके वजह से. एंड अनदर थिंग इज एयर इनग्रेस इन लूबल सिस्टम. For that, as BHL has given a discharge line, vent line is there, 1-inch line in discharge, AOP discharge. This, there is an orifice also in that, and just for keeping the air out of circuit, this vent wall has to be kept track open so that air in the AOP line section has been dispersed. So by this, we have at present we are not facing any problem in AOP changeover. We are doing our as per PM schedule. We are doing the changeover and running successfully right now. This is the issue in bearing number 1. We have a high vibration bearing number 1, around 200 microns. And then we have tripped the unit for once it has gone up to 320 microns. And the unit has been tripped once, and 3 times overspeed trip device has been malfunctioned in that unit. After dismantling the bearing number 1, we have found that this is the side pad. I think everyone can see this. This is the side pad of the bearing number 1. Here there is, you can see a gap in between pad and this pedestal, side pad and this pedestal. Around 0.5 to 1 mm clearance is there after dismantling the bearing. Due to vibration, the pitting also happened here due to bearing and this side pad. We have replaced the bearing and side pads also. For resolving this issue. एक्चुअली ये प्रॉब्लम 10 साल पहले रिलायंस धानु भी होता था. तो जब 1 नंबर बेरिंग का रोटर जब चलता था, 1 नंबर को बेरिंग के साथ रोटर भी मूव होके जाके ओवर स्पीड ट्रिप डिवाइस पे ट्रिप होता था. ये केस स्टडी हमने हमारे ईटी टाइम में पढ़े थे. तो हमने प्रिज्यूम किया था कि सेम इंसिडेंस यहाँ भी हो रहा है, क्योंकि हम लोग इसके क्रॉस चेक के लिए वाइब्रेशन के वोल्टेज मेजर करते थे पैरेलली. जब भी हमारा ये यूनिट ट्रिप होता था, उसके बारिंग गियर के वोल्टेजेस 3000 के आरपीएम में वोल्टेजेस मेजर करके उसको क्रॉस चेक करते थे. तो हमारा पूरा बेरिंग के साथ हमारा रोटर भी शिफ्ट होके एक साइड में आता था. एक साइड में वोल्टेज हाई मिलता है, एक साइड में वोल्टेज कम मिलता है इसके वजह से. तो एक तो वो रीजन था, और दूसरा ये जब ये साइड पैड घिस गया है, या इसमें एक्चुअली शिम्स थे, 3 to 4 शिम्स थे. शिम्स भी क्रैक हो गए थे ड्यू टू वाइब्रेशन, और इसके वजह से हमारा ये साइड पे ये बेरिंग का जो सीटिंग है, जैसा सर ने बताया था पहले, ये बेरिंग नंबर 1 में फुल कांटेक्ट होना चाहिए. यहाँ आप देख रहे हैं कि यहाँ पे बस पार्शियली इधर फुल कांटेक्ट आ रहा था, इधर बिल्कुल भी कांटेक्ट नहीं आ रहा है. ये जैसा इधर दिख रहा है, इधर कांटेक्ट है, इधर कांटेक्ट नहीं है, इधर भी कांटेक्ट है. इसके वजह से हमारा पूरा बेरिंग और रोटर जो है टिल्ट होके ये प्रॉब्लम हो रहा था. और इसके बाद हमारा वाइब्रेशन अभी ऑलमोस्ट 100 के नीचे आ गया है, और अभी सक्सेसफुली ये काम हो गया है. इसमें लर्निंग ये है, जब भी हमारा वाइब्रेशन आता है, उसके साथ साथ अगर बेरिंग में कोई हेल्दीनेस है नहीं है, चेक करने के लिए वाइब्रेशन के जो वोल्टेजेस है वो मेजर करके पहले रिकॉर्ड करें बारिंग गियर में, और 360 आरपीएम में और 3000 आरपीएम में. तो एक हम को क्रॉस चेक के लिए मिल जाएगा वो. एक इंसिडेंस हुआ था जुलाई 22 में, एक बार यूनिट ट्रिप हुआ था इलेक्ट्रिकल प्रोटेक्शन की वजह से. तो उसमें क्या हुआ था कि बारिंग नहीं आया था. तो हम लोग नॉर्मली जो टर्बाइन वाले जो करते हैं वही प्रैक्टिस अपना है, प्रेशर वशर चेक किए जेओपी का. तो एज पर पुराने रिकॉर्ड्स के हिसाब से हमारा जो जेओपी प्रेशर मिलना था, बेरिंग 6 में बहुत कम प्रेशर मिल रहा था, हार्डली 30-40 kg मिल रहा था। नॉर्मली 110-120 डिग्री 120 प्रेशर रहता है kg पर सेंटीमीटर स्क्वायर। तो उसके लिए हम लोग उसका ये समझ में आ गया था पहला दिन ही कि प्रेशर जो है इसका डाउन आ रहा है, तो कुछ ना कुछ बेरिंग नंबर 6 में इश्यू था। तो हम लोग फिर ऑयल कैचर खोले, उसी का बारिंग तो बंद ही था, ऑयल कैचर खोल के देखे कि जेओपी होस फटा हुआ मिला उसका। तो हम लोग तो उस समय तो बेरिंग होस चेंज कर दिए, बॉटम ऑयल कैचर निकाल के, तो बेरिंग तो रोल हो गई, मशीन रोल हो गई, फिर यूनिट तो चल गई। फिर अचानक मार्च 21 को फिर यूनिट ट्रिप हुई थी, जुलाई से मार्च तक यूनिट चली है। उसके बाद यूनिट जब रोल हुआ था, मशीन तो बारिंग में आ गई थी, तो जब रोल हुआ था पॉइंट नंबर 6, बेरिंग नंबर 6.20 1920 दोनों इसके ये पॉइंट्स हैं। तो उसका एक टेम्परेचर जो है शूट अप हुआ था, 78 से 100 डिग्री गया था। और 19 तो सेम ही था। हम लोग सोच रहे थे कि बेरिंग टिल्ट हो गया, स्पेरिकल बेरिंग है तो हो सकता है वापस आ जाएगा, ये फिंगर्स क्रॉस करके बैठे थे, तो आया नहीं था। फिर नेक्स्ट ओवरऑल नेक्स्ट एक बार नेक्स्ट दिन ही यूनिट ट्रिप हुआ, फिर अचानक तो सॉरी 22 जुलाई को जब आया था, तब हमारा ये वाला इंसिडेंस हुआ था कि 81 से 91 हो गया था। जब मार्च में गया था तो 78 से 100 हो गया था। ये बेरिंग शूटअप का डेटा है। तो 22 को फिर बीटीएल हो गया था, तो हमने सोचा कि क्यों ना हम लोग दोनों टेम्परेचर बढ़ गए, ऑलमोस्ट 100 एक पहुंच गया, एक 91 हो गया, तो बेरिंग खोल के देख लेते हैं। तो फोर्स कूलिंग किया और मशीन को बेरिंग नंबर 6 का इंस्पेक्शन करना चालू किए थे। तो उसमें एक तो बेरिंग तो फेल्यूर मिला ही है, उसका बेबिट ये हो गया था, वाइपिंग हो गया था। ये इसका रीजन जो हुआ था, जो पहला इंसिडेंट जो हुआ था जुलाई 20 जो 22 में जो हुआ था, उस समय जब बेरिंग फेल्यूर हुआ था, उस समय का ये डैमेज है। ये धीरे धीरे क्या है, क्लियरेंसेस को कम करते गया, बेरिंग का टॉप टॉप ऑयल कम किया, और उसके वजह से हमारा बेरिंग का टेम्परेचर बढ़ रहा था। फिर हमने इसको बेरिंग को इसी बेरिंग को डाल के वापस बॉक्सअप कर दिया है। नया बेरिंग में कुछ इश्यूज थे, तो नया बेरिंग भी यूज नहीं आया, तो यूनिट को लाना था, तो इसी बेरिंग को डाल के हम लोग अभी चला रहे हैं। हाँ, इसमें लर्निंग ये था कि जेओपी के होसेस में जो कनेक्टेड है, उसमें क्लैंपिंग का बहुत ज़रूरी है। ये हमने रूट काज का जो हमारा फॉर्मेट्स है, वो सब उसमें एनालिसिस करते हैं क्यों फेल हुआ, क्या क्या रीज़न था। उसमें एक रीज़न ये था मेजर कि जेओपी का जो होसेस में जो क्लैंपिंग होना है, अगर वो नहीं हुआ है, वो कोई भी मेटल पार्ट से रब होके या हिट होके जब भी स्टार्ट होता है स्टॉप होता है, वो कहीं भी मेटल पार्ट में टच होता है, तो इम्पैक्ट से वो वेर एंड टेयर होके जो भी होस फटने का चांसेस ज़्यादातर है। खास करके 6 और 7 में बहुत ही सेंसिटिव है, इंसुलेटेड होसेस है, तो इसमें बहुत ही सेंसिटिव है, होस फेल होने के चांसेस बहुत ज़्यादा है इसमें। कुछ लोग तो सो गए हैं, बहुत बोरिंग है लग रहा है। जेओपी ओसेस तो बीएचएल से आए थे, तो बीएचएल वाले भी फेल हुए हैं, ऐसा नहीं है कि बीएचएल के फेल नहीं हुए हैं। उसके बाद ओईएम उसके जो सब वेंडर्स है उससे भी खरीदे हैं, वो भी फेल हुए हैं। मेन रीजन इसका ये था कि जेओपी के क्लैंपिंग जो था इरेक्शन से ही नहीं हुआ था, तो हमने उसको इम्प्लीमेंट किया है, तो अभी कोई भी फेल्यूर उसके बाद नहीं हो रहा है। कैंपिंग से प्रोविजन नहीं था, ये बीएचएल का एक हाँ मॉडिफाई किया है। मेजर जो फेल का जो रीजन है सर, जहाँ पे हमारा होज जो टकरा के मेटल से वही फेल हुआ, जहाँ पे मेटल मिनिमम हम्म, 200 का सर। ये बीएचएल का सर्कुलर भी अभी दिया है, तो इसमें लेंथ सही था सर, लेंथ सही था, मगर क्या है, जो जब झटका आता है जेओपी चलने के बाद, जो होसेस में जो झटका आता है, वो इम्पैक्ट जरूर मेटल से मेटल होगा ही। सर वो जो बीएचएल, हाँ, नहीं पार्कर का ही मटेरियल है हमारे पास भी। हाँ ठीक है, हमने क्वालिटी चेक भी किया है सर, हाइड्रो प्रेशर भी उसका 210 kg पर सेंटीमीटर स्क्वायर रखा है, उसके बाद भी फेल हो रहा है। तो मतलब हम लोग को तो रीजन यही मिला है कि जो जहाँ पे हमने क्लैंप लगाया है, हाँ हम तो रिप्लेस कर रहे हैं। अभी सीमेंस का हो, अभी कोई है तो सीमेंस का रिप्रेजेंटेटिव बता सकते हैं। दे आर गिविंग 6 years गारंटी फॉर होसेस, टेफ्लॉन होस, मगर 6 years का वो बोलता है कि टेफ्लॉन होसेस दे रहा है सर, तो वो ज्यादा एफिशिएंट है और ज्यादा। नहीं जेओपी हम लोग उसको डेली रिकॉर्ड करते हैं, जेओपी बैक प्रेशर जो है 6 7 8 का, तो डेली मॉनिटर करते हैं उसका, डेली। अच्छा ये आप जो बोल रहे हैं ना सर, जो हमारा रोटर चलता है तो जो एयर जो चलता है, मतलब वो एरिया में एक एयर भी रहता है प्रेशर के साथ। जेओपी प्रेशर तो नॉर्मली रनिंग कंडीशन में नहीं रहेगा, तो 3000 आरपीएम में जब रोटर घूमता है तो उससे भी थोड़ा सा वाइब्रेट होकर होस्ट कांटेक्ट में, कंटिन्यूस कांटेक्ट में रहता है मेटल के साथ। एज ए रबर या ये बोलो इंसुलेटिंग मटेरियल, क्या है वो वीर एंड टेयर तो होना ही होना है। हमारा तो रीजन यही मिला है कि वो फेल्यूर ड्यू टू रबिंग ऑफ मेटल। हम्म हम्म ये फेल्यूर के लिए सीमेंस ने अपडेट किया है, टेफ्लॉन होसेस लेके आ रहा है इन प्लेस ऑफ रबर होसेस। पूरा मेटल, मतलब मटेरियली वो पूरा टेफ्लॉन का लेके आ रहा है। बहुत कॉस्टली है, 10 times पड़ता है नॉर्मल होसेस से। ये 60 70 thousand का ईच होस का रहता है, वो 6 lakhs पर होस कोट कर रहा है। नहीं सीमेंस तो 60,000 में देता है सॉरी बीएचएल तो 60,000 में। मैं आपको पीओ को अभी शेयर करता हूँ। चलिए एक और हमारा केस स्टडी है, स्टेप ब्रदर जी। हम्म। हाँ नहीं मैडम, क्लियरेंसेस नहीं बढ़े हैं। इसमें क्या था कि एक जगह हमारा जो बेबिट निकला है, वो नॉन कॉन्टैक्ट एरिया के पास यहाँ पे बराबर आ नहीं रहा, ये वाला एरिया से हमारा वो जो बेबिट निकला है, तो वो वाला हमारा क्लियरेंस। स्क्रैपिंग यही जो हमारा ब्लू कॉन्टैक्ट जो आता है जनरल के पास, ये बेडिंग वाला, बेडिंग वाला, इसी एरिया में हमने स्क्रैपिंग किया। चलिए नया बेरिंग जो है उसमें भी कुछ इश्यूज थे, बीएचएल सप्लाई बेरिंग था, 4 साल से आगे पड़ा था, तो फाइनली हमारा लग नहीं पाया था। एक तो एरेक्शन से जो ब्लू कांटेक्ट जो होके मशीनिंग, मतलब साइड पे जो ब्लू कांटेक्ट बना बना के वाइब्रेशन के लिए जो काट देते हैं, वो ओडी में या ब्लू कांटेक्ट बेडिंग के लिए जो काटते हैं, उसकी वजह से हमारा बेरिंग का जो ओवरऑल साइज जो है 0.7 0.8 mm डाउन था। मतलब ओडी में अगर कंपेयर करेंगे तो एग्जिस्टिंग बेरिंग जो है 0.7 0.8 mm डाउन था। तो उसके वजह से हम लोग नया बेरिंग इसीलिए नहीं लगा पा रहे थे क्योंकि हमने डीकपल भी नहीं किया था इधर। ये 6 नंबर है मैडम, सैडल टाइप है, सैडल टाइप है। तो हमने डीकपल भी नहीं किया था, तो हम लोग को अगर वो बेरिंग लग जाता, इफ हम लोग डीकपल कर देते, एंडशील्ड उठा देते, या उस कंडीशन में सेंटरिंग भी करता, इधर कंप्रेसर का भी सेंटरिंग होता, फिर बैफिल रिंग का भी सेंटरिंग करना पड़ता, तो हम लोग को उतना, हम लोग पार्शियली 2 दिन के लिए बेरिंग रिप्लेसमेंट के लिए शेड्यूल काटा था, तो हमारे कमिटमेंट्स भी था, तो थोड़ा सा डिले जरूर हो गए थे वो बेरिंग को लेके आने में। ठीक है, और कोई डाउट था इसमें? ये एक हमारा जनरेटर कूलर में वाइब्रेशंस थे, अराउंड 20-25 तक जाता था सेंटर में, और साइड्स में जो है 14-15 भी आता था, और ये कंटिन्यू रहता था। इसके वजह से हमारे बहुत सारे पाइपलाइंस जो है, प्राइमरी वाटर के पाइपलाइंस, बेलोस पे इम्पैक्ट आता था, और क्रैक्स तो हो ही जाते थे। इसके जो इनलेट जो आउटलेट पाइप्स जो है डीएमसीडब्ल्यू के, इसके भी वेंट लाइंस क्रैक हो जाते थे, बहुत सारे इश्यूज रहते थे, तो हम लोग उसका भी बहुत एनालिसिस किया है। एक तो हम लोग सपोर्ट्स जो है थोड़ा सा फ्लेक्सिबल रखा है विथ रेस्पेक्ट टू डेक, और नीचे हैंगर सपोर्ट्स दिया ही है बीएचएल ने, तो वो हैंगर सपोर्ट्स का हेल्दीनेस चेक किया था, और उससे भी रिजॉल्व नहीं हुआ था। पहले हम लोग सोचे कि पाइपलाइन में स्ट्रेसेस है इसीलिए वाइब्रेशन आ रहा है, तो उसमें भी रिजॉल्व नहीं हुआ। बेरिंग का 6 और 7 में जो वाइब्रेशंस होते हैं उसका इम्पैक्ट तो नहीं आ रहा है जनरेटर के ऊपर, वो भी किए थे, तो बेरिंग्स पे नॉर्मली 40-30 माइक्रोन से ज़्यादा नहीं था, और तो वो भी आने का चांसेस बहुत ही कम था। तो उसके बाद हम लोग जब ओवरऑलिंग किए थे, तो बॉटम में हाउसिंग का जो बॉटम में जो होता है, एक एल क्लैंप होते हैं, ये करीब 8 क्लैंप लगते हैं नीचे बॉटम में। ये एल क्लैंप होना चाहिए एंडशील्ड के साथ, हाउसिंग को बांध के रखता है, कूलर हाउसिंग को। ये इसके बीच में क्लियरेंस भी मेंटेन करना है, ये होल में डाल के, और यहाँ बोल्टिंग होता है, तो ये वाले क्लैंप्स भी नहीं लगे हुए थे हमारे यूनिट में। तो ये एक मेजर फाइंडिंग था, जो वाइब्रेशन को जो है अभी 5-6 के आसपास लेके आ गया है, तो एक लर्निंग है। तो ये वाला क्लैंप्स जो है एरेक्शन में बहुत सारे लोग मिस कर देते हैं, हाउसिंग डाल देते हैं, ऊपर से बोल्टिंग कर देते हैं, इसके वजह से हमारा एक इश्यू और भी होता है, वाटर बॉक्स के बोल्ट शेयर आउट हो गए थे पूरे टॉप में, और अंदर में हमारा हाइड्रोजन था, थोड़ा सा हमने रिस्क लेके न्यूमेटिक ड्रिल मशीन से उसको ड्रिल किया, और बोल्ट्स को निकाल के रिप्लेस किया था रनिंग यूनिट में। सर ये एकदम बॉटम में रहेंगे, कूलर हाउसिंग जब जाता है नीचे, तो उसके नीचे में सर ये क्लैंप्स लगते हैं। हाँ, इसीलिए मैं जेपीएल के प्रॉब्लम्स को ही कवर कर रहा हूँ, ये जो अभी आप लोग भी लगा दिए हैं। हाँ, ठीक है। एक ट्यूब लीकेज हो रहा था एमओटी कूलर में, जिसका नॉर्मली जो एडी करंट से हम लोग कंडेंसर का, हीटर का, सबका एनालिसिस कर लेते हैं, और उसका थिकनेस मेजर कर लेते हैं। तो एक हमने इनोवेटिव एक एकोस्टिक पल्स रिफ्लेक्टिव इंस्पेक्शन एक होता है, वो हमने किया है, एपीआरआई के नाम से जाना जाता है नॉर्मली। वो उसमें हम लोग का ज़्यादा ये है कि रिजल्ट्स पक्का मिलते हैं इसमें, कितना भी क्लियरेंस है, क्योंकि हमारा ट्यूब के गोल में फिन्स रहते हैं एमओटी कूलर में, तो इसमें क्लियरेंसेस मतलब फेल होने के चांसेस, मिलने के चांसेस, अगर ट्यूब लीकेज भी है तो उसका मिलने के चांसेस एडी करंट में कम है, चांसेस उसमें भी मिलते हैं, करते भी है लोग बाग, अभी तक तो कर रहे हैं, मगर ये एक थोड़ा सा अभी नया टेक्नोलॉजी है जिसमें हमको और मिल गया है, लीकेज मिला है, और हमने अटेंड भी किया है 3 ट्यूब लीकेजेस में। ये 3 ट्यूब लीकेजेस में वो बताया है कि हमारा थिकनेस कम है, और 2 में ट्यूब लीकेज बताया है। ये इसका प्रिंसिपल है, जो साउंड पल्स एयर मीडियम भेजता है, और रिफ्लेक्शंस को मेजर करके ये करता है, उसके रिजल्ट्स भी यहाँ पे है। ब्लॉकेजेस 15% दिखाया था, वॉल लॉस 35% था। इसमें एक ट्यूब वो जो दिया है रिपोर्ट में, उसके साथ जो रिजल्ट्स आए हैं, 2 ट्यूब लीकेजेस, 2 को हमने डमी किया था। इतना माइनर लीकेज था कि वो चला भी सकते हैं, और मतलब ऐसा ट्यूब लीकेज था कि हम लोग को ऑयल लाइन चार्ज करके भी रखे थे 3-4 दिन तक, एक बूंद तक नहीं आया। मगर सर्विस में लेते थे तो वो ट्यूब लीकेज आ जाता था और ऑयल का मॉइस्चर लेवल बढ़ा देता था। एक नया टेक्नोलॉजी है, वो इम्प्लीमेंट कर सकते हैं आप लोग जहाँ भी यूज करना है। एक हम लोग का जो, जी हाँ, नहीं नहीं, वाटर में ऑयल ट्रेसेस मिल रहे थे। वा- नहीं, देखिए इसमें हमने एक तो कंट्रोल कूलर के सैंपल्स लिए थे, उसमें 0.01% भी नहीं दिखाता है। इतना माइनर लीकेज था, मेजर लीकेज होता तो तुरंत पकड़ में आता, छोटा लीकेज है इसीलिए उतना जल्दी पकड़ में नहीं आ रहा था। एक वो था, और दूसरा हमने जो कूलर लाइन पे था, स्टैंड पे कूलर था, उसको भी हमने चार्ज करके रखा था वेंट के थ्रू या इक्वलाइजिंग के थ्रू। तो वेंट कंटिन्यू 3-4 दिन गर्म होने के बाद भी एक बूंद भी नीचे नहीं आता था। कूलर में लीकेज था, मगर सस्पेक्ट ट्यूब कौन सा था वो आइडेंटिफाई नहीं हो रहा था, तो हमने इसको अपनाया था। ये आरुद्रा भी करता है, और भी एक पार्टी है, मैं नॉर्मल एनडीटी वाले, मतलब ये हो सकता है वो लोग के पास हो ना हो, एक बार पता करना पड़ेगा। एनडीटी नॉर्मली जो करता है वो कर लेता है। एक हमने कंट्रोल फ्लूइड का जो टैंक है उसका ब्लैंकेटिंग का एक ये किया है। हमारा कंट्रोल फ्लूइड का टैन वैल्यू 1 यूनिट में बहुत ज़्यादा बढ़ गया था, तो उसके लिए हम लोग दूसरा यूनिट के लिए हमने प्रिजर्वेशन का ये किया था कि छोटे नॉर्मली यूनिट्स में, जो अब लोग टर्बाइन वाले हैं तो सब जानते हैं, जो एलपी वेपर्स एचपी वेपर्स में 1 KL 2 KL कैपेसिटी में ऑयल में करते हैं नॉर्मली, तो 16 KL कैपेसिटी में ये करना थोड़ा सा टफ है, और हमने इसको अपनाया है और बहुत अच्छा रिजल्ट है इसका। नॉर्मली मॉइस्चर लेवल जो रेन पीक रेनी सीजन में 1100 तक चले जाता है मॉइस्चर लेवल में, तो 980 लिखा है, 1200 भी जाता है मॉइस्चर लेवल, तो वो अभी हमारा अराउंड 700 650 के आसपास मेंटेन हो जाता है। पीक समर में तो 400 ऐसे आ जाता है। इसमें हम लोग ये टैन वैल्यू भी जो है पॉइंट रेजिंग ट्रेंड से अभी वो डाउन आते जा रहा है, 0.7 से लेके अभी 0.29 तक आ रहा है। ये बहुत अच्छा रिजल्ट है, ये कोई चाहिए तो इसका अपना सकते हैं। इसके लिए हमने क्या किया है कि इसका सिंपल डायग्राम ऐसा है कि 2 कूलिंग ये है, 2 टावर्स है, इसमें नाइट्रोजन जनरेटर्स है, विथ कंप्रेसर विदाउट कंप्रेसर दोनों लगा सकते हैं। हमने इंस्ट्रूमेंट एयर को यूज़ किया है यहाँ पे कि कॉस्ट कम करने के लिए। नाइट्रोजन टर्वर्स सीरीज में रहते हैं, तो एक 99% जनरेट करता है, उसके बाद फिर दूसरा भी कुछ एयर के ट्रेसेस हैं। तो अच्छा, इसमें एक नुकसान ये है कि एयर का कांटेक्ट में आएगा तो फिर कंट्रोल फ्लूइड का टैन रिप्लिका हो जाएगा। तो इसका प्यूरिटी भी बहुत ही इंपॉर्टेंट है, रिलेटिव ह्यूमिडिटी और ये पैरामीटर्स पूरे लेने के बाद ही इसको चार्ज करना है। कुछ टेक्निकल हेल्प चाहिए तो मैं दे सकता हूँ। क्या क्या पैरामीटर लेना मैं आपको एक बार और बता देता हूँ, यहाँ मेंशन नहीं किया, मैंने भूल गया था। दो टावर है, 2 नाइट्रोजन टावर है जो जनरेट करेगा, और एक इसके पहले एयर, सॉरी पहले एयर से स्टार्ट करते हैं। कंप्रेसर एयर लिया, उसके बाद हमने रेफ्रिजरेटर है बीच में, फ्रिज जैसा है जो मॉइस्चर कलेक्ट करके कंडेंस करके उसको निकाल देगा जो भी एयर में मॉइस्चर है। उसके बाद वो सैचुरेटेड एयर को इसमें भेजता है नाइट्रोजन टावर में, और नाइट्रोजन करने के बाद जो वेस्ट गैसेस है वो सोलनट के थ्रू बाहर हो जाएंगे। रिमेनिंग जो नाइट्रोजन है इस सिलेंडर में, इसमें टावर में कलेक्ट हो जाएगा। यहाँ से हमने एक फ्लो मीटर देके करीब 70 LPM 60 to 70 LPM मेंटेन कर रहे हैं फ्लो। उसके वजह से हमने एक यूनिट में अचीव कर लिया है कि OVF का भी, जो कंट्रोल फीड में OVF जो लगा हुआ है उसको भी हमने मिनिमाइज कर दिया है, मतलब ना के बराबर फ्लो OVF से जा रहा है। एक यूनिट में अभी थोड़ा सा एक्सपेरिमेंट चल रहा है, उसको भी लाना है। एक यूनिट में तो सक्सेसफुली हो गया है, दूसरा यूनिट में कंट्रोल फ्लूइड का जो वेपर फैन जो होता है उसको थ्रॉटल नहीं कर पा रहे हैं, वो करते हैं तो फिर गवर्निंग रैक में प्रेशराइज होना, ऐसा इश्यूज आ रहे हैं। उसको भी एलिमिनेट करेंगे, देखते हैं अभी रेनी सीजन निकलने के बाद फिर उसको ट्राई करेंगे। रेनी सीजन में इसमें कोई छेड़छाड़ नहीं करना है, मॉइस्चर और टैन को लेके बहुत ही ज़्यादा ये होता है। तो अभी हम लोग एक यूनिट में सक्सेसफुली कर लिया है, दूसरा यूनिट का मशीन अभी आया है तो वो करेंगे। और एक नाइट्रोजन प्यूरिटी मीटर ऑनलाइन भी होना चाहिए इसमें, वो एक बहुत ही अच्छा प्यूरिटी मीटर दिखते रहेगा तो कम से कम पता चल। तो वो वाला क्या, फिर प्यूरिटी ड्रॉप कर देगा तो कांटेक्ट एयर के साथ आ जाएगा कंट्रोल फ्लूइड, तो वो ज़्यादा रिस्की है और एक अच्छा है। अच्छा, ये तो मैं सजेस्ट नहीं करूंगा सबको इम्प्लीमेंट करने के लिए, जो कर सकते हैं। एचपी टरबाइन में ग्लैंड लीकेज था और मैंने जो वो पॉइंट्स भी कवर किया है, खास करके अदानी और जिंदल में जो प्रॉब्लम्स चल रहे हैं उसी को लेके मैंने कवर किया था टॉपिक्स। एक एचपी ग्लैंड में जो लीकेज हो रहा था वो 400 mmWC तक जाता था ये प्रेशर, और एमओटी का मॉइस्चर जो है कंटिन्यूस रेजिंग ट्रेंड पे था, करीब 200-250 तक चले गया था। फिर हमने उसको ये करने के लिए सेंट्रीफ्यूजर्स और 2 एलवीडीएच हाई, मतलब हाथी टाइप के एलवीडीएच लगाए हैं, तो उससे तो मॉइस्चर निकालते थे, मगर प्रॉब्लम जो था ग्लैंड लीकेज था, और हम लोग ओवरऑलिंग भी नहीं कर पा रहे थे क्योंकि हमारे पास स्पेयर्स नहीं थे, सील रिंग्स नहीं थे हमारे पास, ग्लैंड सील नहीं थे, कुछ फास्टनर्स भी प्रोक्यूरमेंट में थे, तो ओवरऑलिंग अगले 3 महीने तक कर नहीं पा रहे थे। तो उसके लिए चलाने के लिए हमने ये किया था कि एक एडिशनल लाइन हमने ये डाला है, सील स्टीम हेडर के बॉटम से हमने अप्रॉक्स 6 इंच का लाइन डाला था, एक आइसोलेशन वाल देके, फिर ये हमने फ्लैश पाइप में जोड़ दिया है। जोड़ के इसके मैं पहले डिसएडवांटेजेस बता देता हूँ कि ये करने से क्या और नुकसान हो सकता है। टरबाइन में जहाँ से लीकेज हो रहा है वहाँ पे स्टीम फ्लो होने के चांसेस के साथ साथ कुछ वेरिएंट एयर वहाँ भी होंगे, तो वहाँ का मेटल कुछ क्लियरेंसेस वहाँ का खराब होने के चांसेस है, तो उसको करने के पहले एक बार ज़रूर ओईएम से कंसल्ट करके करें। और हमने अपनाया था तो हमने इसको रिप्रेजेंट कर रहे हैं। तो हम लोग 540 के आसपास लोड रिस्ट्रिक्शन दिया है, 600 तक तो जा नहीं पा रहे थे, 550 में हम लोग कंटिन्यूस यूनिट चला के सक्सेसफुली इसको इम्प्लीमेंट किया है। हाँ, लीक ऑफ में मार्जिन खत्म हो गया था, तभी तो प्रेशर बढ़ रहा था। एडिशनल स्टीम जो भी जा रहा था हमने इसको यहाँ से बाईपास कर दिया था सिस्टम से, तो लॉस तो है मगर यूनिट चलाना भी था 3 महीने के लिए, एक ये था, तो ये है। अच्छा, इसके हमने वो भी मिला था कि इसके बाद यूसील रिंग जो बड़ा वाला जो है वो वाला क्रैक मिला था, तो हमने उसको रिजॉल्व भी कर लिया था। अच्छा, एक हमारा एक चैलेंजेस है जो प्यूरिटी ड्रॉप हो रहा है, कोई भी आप हेल्प कर सकते हैं, तो इसमें पैरामीटर्स भी हमने दिया है, ये डिस्कशन पॉइंट के लिए लाया था, कुछ प्रॉबल रीजंस कोई बता सकता है तो आप मोस्ट वेलकम। ये क्या है, जनरेटर का प्यूरिटी ड्रॉप होता है 3 to 4 आवर्स के बाद, सिलेंडर पर्जिंग, सिलेंडर टॉपअप के बाद, तो हमने कुछ कुछ किया था, उसके बाद भी सक्सेसफुली अभी हो नहीं पाए हैं। कुछ कोई हेल्प कर सकता है तो एनटीपीसी और ये लोग तो है ही है। हम्म हम्म जी। नहीं, वो तो प्यूरिटी तो सिलेंडर प्यूरिटी तो आप बाहर भी चेक करा सकते हैं। टीसीबी डीएमसीडब्ल्यू में है सर आपका? हाँ, 3 वे वॉल है ना वो तो। हाँ। हम्म। वैक्यूम टैंक के लिए हम लोग भी एक ये किए थे, आप लोग इम्प्लीमेंट करना है तो कर सकते हैं। आप ड्रॉप टेस्ट कर सकते हैं वैक्यूम टैंक का। अराउंड 30 to 40 मिनट्स रहना चाहिए पंप पिकअप करने के पहले। आप लोग 0.1 0.2 ही मेंटेन करते हैं सील ऑयल वैक्यूम टैंक का प्रेशर, तो उसको हो सकता है 25-20 मिनट तक तो आ ही जाएगा आपका। वो ड्रॉप टेस्ट आप लोग कर सकते हैं, कोई लीकेज होगा तो अटेंड कर जा सकते हैं। हम्म। वैक्यूम तो मेंटेन है, हमारा तो वैक्यूम मेंटेन है 0.4 है, उसके बाद भी तो नहीं आ रहा। ठीक है। और कोई ड्रायर रेफ्रिजरेंट टाइप है। हाँ, ड्यू पॉइंट 20 to 23 मेंटेन होता है। हाँ। ड्यू पॉइंट तो 20 to 23 मेंटेन हो रहा है। अच्छा है ड्यू पॉइंट। हाँ, ड्रायर है रेफ्रिजरेंट टाइप। लोअर नहीं है। हम्म। ठीक है, वो तो हमारा तो एक हर साल में तो चेंज हो ही जाता है, फिर भी एक बार करके भी देख लेते हैं। थैंक यू। थैंक यू। हम्म। वो बोल्ट्स में काउंट करते मेरे ख्याल से 4। हम्म। 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 नहीं, 300 में आपको फिर यूनिट ट्रिप होगा, टीडीपी लूबल ट्रिप होगा तो ऑयल कहाँ जाएगा? ओवरफ्लो। हाँ, हाँ। नहीं, एक तो टीडीपी का जो एओपी चालू करने के बाद प्रेशर ड्रॉप नहीं होता है। ड्रॉप नहीं होता, प्रेशर बढ़ता है। प्रेशर। हाँ। हम लोग तो मेन ट्रिप वॉल का ही मेन मिला था। इसमें इसमें आप देखेंगे तो ट्रिप ऑयल प्रेशर के बाद पहले एक रिमोट ट्रिप प्रेशर भी आता है। वो प्रेशर पहले ड्रॉप होता है, जो जो रिमोट इंगेज के बाद जो रहता है आरटी। हाँ हाँ, रिमोट रिमोट नहीं, आप एक बार डीसीएस में एनालिसिस करेंगे तो जो रिमोट ट्रिप सोलनॉइड के डाउन स्ट्रीम में एक प्रेशर ट्रांसमीटर दिया होगा। अगर वो ट्रांसमीटर का प्रेशर सबसे पहले ड्रॉप होता है, इसका मतलब प्रेशर अगर मिली सेकेंड में देखना पड़ेगा आपको। मिली सेकेंड में जब आप देखेंगे रिमोट ट्रिप सोलनॉइड का प्रेशर पहले ड्रॉप होता है, उसका मतलब क्या बोल रहा है कि वहां के आसपास का प्रेशर पहले ड्रॉप हो रहा है। दैट इज मेन ट्रिप वॉल। मेन ट्रिप वॉल के पास ही प्रेशर ड्रॉप हो रहा है, इसीलिए हम लोग को मेन ट्रिप वॉल का ही टारगेट किए थे और प्रॉब्लम रिजॉल्व हुआ है हमारा। ओके, थैंक यू।
Thank you very much, sir, for your wonderful presentation covering these detailed case studies and innovative solutions and best practices. I think everyone has got benefited by these case studies as well as the experiences. Now the time is 1 o'clock, then we can break for lunch. Then these BHL presentations will be in the post lunch. So I request all of you to assemble back by 2 o'clock. Correct, sir? Two. Right. Okay, sir. Thank you, sir. And is there any questions from these online participants? Durgesh, kindly verify that is there any question is from online participation? Uh, Sir, if any questions is chat box. Yeah, that's it. Voice is not coming. Okay. Okay, we can assemble back at 2 o'clock. Okay, meantime, we can inquire with these online participants. If they have any issues, that will be addressed now. Okay, sir. Thank you very much. We will take you, sir. Students, GTC, PGDC students, you just finish your lunch in your hostel and come back at 2 o'clock. Okay. Diploma. अच्छा, ठीक है. Sir, please proceed. Yes, yes, sir. दे दिया, co-host बना दिया.
Recording in progress. Recording stopped. अच्छा उधर कर रहा हूँ।
उधर जो है दिख रही है।
अच्छा 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 उधर दिख रहा है।
हाँ देख, एक बार दिखाइए ना, अभी तो हटा नहीं।
अच्छा
ठीक है ठीक है, अभी हटा दिया।
सर खुला है क्या?
वो सूरज शहर थे वहाँ पे, तो देखा होगा स्क्रीन शेयर।
अच्छा उधर कैसे दिख रहा है?
स्क्रीन शेयर का ऑप्शन आता है, वो आप देखिए
अच्छा
स्क्रीन।
करेगा ना?
Am I audible?
नहीं इस पे
Okay, am I audible? Am I audible? Somebody can confirm.
Yes, sir, you are audible.
Okay, thank you. Okay, my name is Trijay Kumar Nim. I am from BHL Technical Services, Power Sector Technical Services. I have been working in this group since 2000. We specialized in steam turbine. If somebody can project the presentation, that will be yes. This is the presentation, right? So, good afternoon to everybody. I hope everybody is very familiar with BHL uh, and mm, the machines supplied at JPL, 250 megawatt machines and the 600 megawatt machines, and the machines at DB Power and nearby uh, REGL Adani. Earlier it was Avanta Power. These all machines have been supplied by BHL only. Uh, Over the years, you see, we have supplied 210 megawatt machines. That was our standard product. That was a KW design machine. That is a Siemens design machine. Before that, we have supplied 200 megawatt machines of Russian design. That was LMZ sets. And later on, we proceeded to 500 megawatt machines, and in between 250 270 megawatt machines. And lately, most of the machines what we are supplying are supercritical sets. Although uh, besides metallurgy, because of the parametric higher parameters, the metallurgy has changed. Otherwise, the supercritical machines are not much difference than a subcritical machine. You see, the most of the things that happens towards the boiler area, whereas in the turbine side, only due to the higher parameters or higher pressure and temperature, a little bit of higher temperature, I'll say. Because of that, metallurgy gets changed. Only that much is the difference in the turbine side, and some of the technological differences have come up over the years. That is there. So we are here today to talk about some of the ongoing problems or regular problems what we see in a steam turbine area. I think whoever is there from the steam turbine maintenance side or even from the operation side, they will be aware of these common issues, which is one of them is barring gear jamming problem. And once in a while, every person in this area must have actually faced this issue. And uh, this issue deals with many aspects of the turbine. Right? You see, in a KW set, if I talk about the 600 megawatt machines, what we are supplied at Jindal or even REGL or DV power. That is a three module machine. That is, it is a separate HP turbine, high pressure turbine, IP turbine, and LP turbine. So, and the aspect of bearing gear jamming problem, that can actually relate to the manufacturing side. I've actually uh, bifurcated it into three main reasons, which can be manufacturing side or can be erection side, and the third is operation side, right? So on the manufacturing side, as we already know, you see a rotor and a casing. There are very little clearances in between a casing and a rotor, because a rotor is a rotating part. It has to rotate at a 3000 rpm. In Indian scenario, it is rotating at a 3000 rpm, and it is dealing with high pressure and high temperature steam, and a casing is a stationary part. So there are very little clearances in between the various stages, inter stages, and at the end, the casing and rotor also, there are gland seals where the clearances are the minimum. Probably it is of the order of 0.5 or something like that radially. So definitely a rotor and a casing should conform to some norms which are specified as per the drawings. And you see, uh, it can happen. It can happen at some times. Some of the issues can crop up because of the manufacturing, or even that can reflect because of product handling or storage thing, which actually will reflect as a deviation probably in the manufacturing, because a run out, because one of the parameter which is a very critical parameter for a rotor is a run out. And the roll check of a casing, which gives the overall radial clearances, or a bump check of a casing, which gives the axial clearances in a casing. So while handling a module or storing a module, these these clearances can get deviated, right? And over a time, there can be a temporary sag which can happen, which can take place in a rotor, which can lead to uh, uh, overcoming of clearances, and the rotor and the casing, the clearances can breach, so that it will reflect into jamming of the rotor, right? And so uh, besides the quality of the manufacturing, this aspect will also see the handling of the module, or even storage of the module also, right? And so all the drawings or the protocols what we have received should be actually, if time permits, that should be actually matched at site, so that any deviations observed, if observed, should be highlighted in time, right? If that is highlighted in time, and probably that can be corrected also. So people who are dealing this must have uh, seen this, or probably observed this during their tenure of working in this area, probably. So the quality of manufacturing, which will reflect in the deviations, and which can be seen through the assembly protocols during erection time, or even maintenance time, when the uh, module is being replaced, or the, sorry, not exactly the module, I will say, any component is being replaced at that time itself. Any deviation is seen, so that can be highlighted to the OEM, in this case BHL, right? So the second aspect is the erection related. So during the erection, you see, there are when a module is erected, whether it is HP or IP. HP normally it is sent to site in a complete modular base. Complete assembled module goes to site, whether it is 500 megawatt, even 660 megawatt, 800 megawatts. Complete module, assembled module goes to site. But in case of IP, some of the lower mega rated machines, they get the assembled IP, but otherwise in higher rating machines, IP goes in a dismantled condition. That is, the inner casing separate, outer casing case separate, and the rotor goes separate. And these are boxed up at site itself. And I don't want to actually go apprise everybody with the complete erection process. People must be aware of that. How we proceed on, how we decide the center line of a rotor. Then rotor is considered as master, and besides that rotor master, we erect the casing, keeping the overall radial casing, and the loading on the pedestal, and even the axle clearances also, that should be taken care. So erection should be done properly. One of the main aspects what I will talk about is the piping pull, uh, and that has to be checked when the casing is kept in you need to check the horn drop, and horn drop gives you a fair idea of the loading, uniform loading of the casing on the pedestals. Right, two palm of the pedestal will be resting on, two palm of the casing will be resting on the one pedestal, and the palm of the pedestal will be resting on the other pedestal, and we need to check whether the loading is uniform. Uh, you see the casing is not as such symmetrical, so there will be a loading difference in the front and rear side. But we need to see that on the left and right side, the deviation should not be much, and within the required parameters what BHL suggests. So when a casing is erected at that time loading has to be checked, and after all the matching of the piping connections, the inlet, main steam inlet for HP turbine, main steam inlet connecting the breech nut, connecting the CRH line, all the extraction lines. After connecting that also, we need to do the horn drop test. And again, the deviation before actually connecting the pipeline and after connecting the pipelines, the deviations are acceptable, should be in the acceptable limit. That is around I think 40% of the deviation is allowed, and at that condition. So that needs to be seen by doing the pipe pulling, the horn drop. So any pipe pulling coming to the module should be avoided. That means the pipe being connected to the module should have a zero force on them. There should not be any pull to them or push to them. So when they are connected to each other. So the next is insulation, insulation. Though although I will say people consider it to be a very low tech area, but that has to be it has to be given proper importance. You see any deviation, uh, we have to be on the rear past slide only, previous slide. The erection aspect we are talking about, it is in the previous slide only. Previous slide. Yes, we are talking about the insulation part. So insulation itself is a very important aspect. Any uh, uh, lesser insulation applied on one part, or a higher insulation applied on one part, will give you a deformation, or sort of deformation, which can actually lead to breaching of internal clearances and may lead to bearing gauge jamming. You see, in some of the cases, uh, you must be also aware with that when we are applying insulation in the bottom side, there is a tendency of the insulation hanging by gravity. It can come down. So the insulation, the proper insulation gets affected, and because of that, probably there can be deviation in the top bottom temperature, leading to some casing deformation, which can actually lead to bearing gear jamming. Right. So proper importance to insulation has to be also given. So in subcritical machines, the condenser also is actually resting on spring support, and mostly the turbine what BHL has supplied are supported on the rigid support, and you must be aware about the spring support also spring supported TG deck, uh, and mostly the spring support of the TG deck, it is supplied by springs are supplied by GURB, and most of the turbine supplied to NTPC, they are resting on the spring support. But the condenser is also mounted on a spring. So we see all the operating load has to actually come on this condenser spring, right? And all, sorry, on the deck itself, and all the fixed support, it is going to the condenser spring in the bottom. So you must be seeing during the erection time, this condenser springs are locked, the jacks are locked, and when the erection is completed, you have to see that these jacks are properly loosened, and the condenser load is coming on these spring support itself. Suppose if we forget to actually remove these jack, so whenever the machine comes to operation, the any small thermal deviation will be reflected in the LP side, and there are the minimum clearances in the gland box area where the clearances can get breached. So bearing gear jamming can occur in that in that condition. So next slide, please. The next aspect is basically operation related. Uh, Besides manufacturing and erection related part, operation plays a very important role in that. Uh, and I will say, normally what happens whenever, mostly in the case of unit tripping, we have seen the rotor directly going to a zero speed, and the bearing gear is not holding. You see, there is a procedure condensing system shutdown procedure is provided in our O&M manual, and I will say the people should actually follow that. There is a proper procedure for shutdown of the condensing system, right? So you have to follow that, and the seals team, uh, for the seals team also, we have issued some of the circulars, and these circulars are sent to all the operators, and I hope you people must also be having those circulars, and those circulars should be actually followed. Like in case of a hot machine, when the rotor is in the hot condition, there are some required condition for a seals team. So seals team should be having some parameters, and below that either you have to actually cut off the seals team, or you have to maintain the parameters, because in case of a hot rotor, if you provide a uh, cold steam, that can probably lead to breaching of clearances in the segment length segment area, and that can also lead to bearing and jamming. And I will say this is the most common and prevalent problem what we have faced, and most of the times what we see, and when we get the data from various customers. Normally, what happens? The boiler gets stripped, and in that condition, when the seals team provided auxiliary PRDS, there is no other support of auxiliary PRDS. The parameters are not kept as per the requirement, and cold steam is provided to a hot rotor, and that in that condition the rotor gets jammed. So that has to be actually taken care, and accordingly the condensing system shutdown procedure has to be followed, right? So, as we know, gland steam header, which is actually supplying steam to the glands during the startup time, or even the tripping time also, when there are no self sealing or available, or leakages from the HP side or the IP side, to maintain the parameters of the header. Uh, at that time, the gland steam is provided from the auxiliary PRDS. Otherwise, steam is leaking from the higher parameters, and it is going towards the LP side and maintaining the parameters. But you see, the spindle leak off of the walls, that is also actually connected to the this header, and in case of wear out of this wearing of this spindle glands, the higher leakage is observed, and this higher leakage leads to higher temperature in the header, and higher temperature in the header of the gland steam, it will lead to higher parameters towards the LP side. You see, in the LP side, there are only two path. One is seal steam actually supply side, and the other part is actually that is connected to the gland steam condenser. The leak off is there. So if we provide higher parameter steam there, there are a lot of chances that the gland box, which is the sealing area of the LP, that can get deformed. And then in many conditions, we have seen that also because of the higher parameter. This happened, and the gland box was found distorted when the machine cools down, and at the end, when you are checking, we find that gland box is found distorted. So that has to be avoided, and any higher leakages, spindle leak off should be avoided, and the glands should be properly changed to avoid this leak off. Uh, Further, the casing drains, at the HP casing drain, the MAL 22 or even the MAL 81, which is there in the gland stream header, we have to see all the MAL drains are properly working, and whenever the unit actually trips, all the MAL drains get open, so that there is no condensation in the casing, which may lead to uneven cooling of the casing, and can lead to distortion of the casing, right? And in case of a MAL 81, this particular MAL drain is connected to the gland stream header, and it has also, besides the one wall, it has also a separate parallel line with the orifice. So in it takes care that always the MAL, the gland stream header should be having some of the flow, so any condensation taking in that header should be removed to the condenser. So we have to ensure that this line, the parallel line in the MAL 81 line, that orifice is not getting choked. We have to take care of that, right? Then during the startup of a machine, you see, normally nowadays, because of solar power ingress into the grid, during the daytime, because of the solar power, all the thermal power station, they need to actually uh, either they have to trip or they have to bring down that load. And this regular operation of variation of load, or even uh, regular startup, many a times actually we have seen nowadays two shift operation is taking place. So machine is started during the night time, evening time, then again it has to trip when the solar power comes up. So during every rolling time, these parameters are very critical. You have to take care whether it is a cold start, it is a hot start, or it is a warm start. You have to take care the steam parameters what we are provided. It should be as per the prescribed norms. You should not actually put the cold steam into the turbine. uh, that will definitely lead to bearing gear jamming, and in some of the cases we have seen that also. The unit was in a tipped condition, and the only within 24 hours, when the operator has tried to restart the machine, and in some hurry or something, uh, they have bypassed the criterias and put the cold stream into the turbine, which has actually led to bearing gear jamming. You see the heater levels and the deator levels. The extraction is actually coming from the turbine side to these heaters, and even deaerator also. So any rise in the level of the heater or the level of the deaerator, it may happen that overflow of water can go into the turbine side. Although there is an extraction wall, there is an NRV, but these NRVs not are not exactly that leak proof, and it may happen that overflow of a heater uh, can lead to that water can go into the turbine. So we have to ensure that the drips are working fine, and any increase in level of a heater that should be taken care by the cascading drip, or the bypass drip, which is directly going. In the case of HP heater, it is going to the deaerator, or in case of the LP heater, it is going to the condenser side, right? So that have to ensure there should not be any accumulation of water besides the required normal level. That should be ensured. Next slide. Okay. This is also a very regular problem, and we have highlighted this uh, because I have earlier mentioned also. NTPC machines are mostly spring loaded, having a spring loaded TGDAC. And in that condition, whenever any AC power failure takes place, in that condition, definitely CW will not come into service. And when CW doesn't come into service, uh, and CEP is also not into service, there will be definitely a very high deviation in the hot well level, which will actually, as I was telling, that any operating load, it is going on the condenser, and it will actually reflect on the TG deck itself. So the spring, or the TG deck spring, will further go down, and it will lead to breaching of the internal clearances of the turbine, mostly in the LP side, where the gland box is there. So this happens normally. We have seen this. So in case of a AC power failure with the spring loaded TGDEX, it gets really difficult to save the machine from bearing gear jamming. Further, the catenary is a very critical erection criteria. You see all the the catenary is basically a natural uh, sorry, a natural sag of a rotor. As we know, any rotor when kept on two simple supports, it will have a natural tendency of a sagging. And when number of rotors are connected together, coupled together, we have to maintain a natural that sag of complete rotor system. And in case of a spring loaded TG deck, uh, uh, that also we have seen. In case of a spring loaded TG deck, the reliability of springs are little doubtful, and that has also been raised to the supplier also, and that is why BHL has very strongly defended it to not to use spring loaded TG deck. At many platforms we have favored that only rigid type of spring support, only rigid type of TG deck should system should be there, foundation should be there, and people should not go for the spring loaded TG deck, because over the time the tendency of the springs is that springing system, the quality of springs actually goes down, and the margin of correcting the catenary or they have also actually raised this issue because they had no margin of uh, correct. You know, correct. Uh, in the spring loaded TG deck, the can also lead to over the time jamming of bearing to be checked at all the any correction if it is there of this catenary. Sorry, just a minute. Am I audible now? Is the voice clear now? Proper net connection is there, but I don't know why. It is okay now. Okay, so I was talking about the loaded TG deck in case of AC power failure. We have seen, just a minute. Yes. In case in case of a spring-loaded TG deck, it becomes really hard to save the machine from barrier jamming in case of AC power failures. And in case of spring-loaded TG deck, there are very less means of correcting the catenary uh, over the years. The margin gets shrinked, so catenary correction becomes almost like impossible. So that also leads to Barigian jamming. Next slide. Can we go to the next slide, please?
Straight change. Durgesh. Okay.
Yes, we have seen that how what are the all the aspects which can lead to actually barring gear jamming, and next is what to do during when we see barring gear jamming. So some of the critical parameters are there that needs to be actually seen and analyzed. I've already touched upon the seal steam parameters, and besides that, you have to see the main turbo auxiliary parameters. The shaft vibration, the bearing vibration, axial shift, the differential expansion, uh, and the HPT, IPT, top bottom casing differential temperature, COTC, because all these parameters will have effect. It will be showing that where actually the rubbing has taken place, right? So that is the seal steam parameter that is very important part to play. And when the machine comes on the barring gear, lube oil parameters are very, very important. So you have to note down the lube oil temperature, pressure, and the jacking oil temperature pressure also. You have to note down the bearing metal temperature and the drain oil temperature as well, because the drain oil temperature will show you what was the whether any damage has taken place in the bearing or not, right? Besides the bearing metal temperature, that will be shown the drain oil temperature as well, right? Next slide. Okay, and what you need to do when the barring gear jamming occurs, right? So this is what you need to avoid. Actually, you should not do in case of a barring gear jamming. Barring gear is not getting restored. That means barring gear has got jammed even after HP shaft temperature has come down. You see on a normally when we observe in case of 500 megawatt machines, normally it happens that around 280 degrees Celsius for HP shaft temperature, we see if any normal jamming has taken place, or a temporary deviation has taken place, that will be normalized, and the rotor should get it should be able to rotate. But if it is not happening, then in that case you should not actually force the rotator to rotate, because in that condition you may actually give more problem to the turbine, right? So that you have to avoid. I know it is easier said than done. People tend to actually bring the unit back to restore the unit and rotate the rotor so that you are able to rotate the machine and uh, again operate the machine. But if you force the rotor, it may lead to higher problems, more problems. Next slide. So what you need to take care is you have to follow the O&M practices as mentioned in the steam turbine. As I already told you, there are some of the guidelines which you need to see, like the condensing system shutdown sequences that you have to follow, and time to time BHL has given some of the technical circulars we have already issued. So you need to actually follow these technical circulars. I hope uh, all the concerned people they regularly received the guidelines. Recently, I don't think any new guidelines have been issued, but some of the technical circulars which are relevant to this barring gear jamming issue that has been issued. So next slide. So these are the beside all the parameters, these are turbo advisory parameters that these need to be analyzed. Next, these are the parameters. Normally, whenever we get a feedback from any customer, we ask the customer to give the trends of these parameters, and based on these key parameters only we analyze and we come to some conclusion what can be a problem besides the history of the machine. That is also a very important thing, right? Next, so these parameters you note down. Next, these also are the key parameters. Next. So next very common problem is low vacuum problem, and as we know, normally uh, we keep vacuum in the condenser side, and condenser is a very big fabricated structure, and normally when you uh, uh, keep vacuum in the condenser, there will be a chances of air ingress, because the negative pressure will definitely see that from the atmosphere air will be sucked inside, and that will actually reduce the vacuum itself, and that this is the actually main common problem. Although we the vacuum pumps or the ejectors are provided to remove those uncondensable gases, non-condensable gases, which goes into the system because of the vacuum. So vacuum pumps or ejectors are provided for that, but they are also having a limited capacity, and normally a vacuum pump is able to take away to around, I think, 100 or something kg of per hour of the non-condensable gases or air, but it is allowable to around 40 kg per hour of the ingress is allowed. Beyond that, it can create problem, and the overall efficiency of the system will go down also, right? So we have to maintain the vacuum in the condenser, and the main problem what we see, besides the other problem, I will say that there can be a problem in the cooling water system. There can be a problem in the because of the cooling water system, there can be in the tube scaling can form. Besides that, the main problem is because of the air ingress. So for air ingress, what we suggest is mainly two methods are there. Water fill test, we carry out that, and the second thing is the steam pressurization test. So after water fill test, which covers the main area up to which water can be filled, beyond that, we have to do the leakage test in the by steam pressurization test in the LP side, the portion which is under the vacuum, kept under the vacuum, that has to be checked through the steam pressurization test. These two tests can be done when the unit is under shutdown. Otherwise, during operation also, there is a method called helium leak detection test that can be done. That is also suggested, right? Next slide then. I've mentioned some of the issues because of this poor condenser vacuum, what it can lead to, right? All these things are I've already mentioned. I'm touching upon why this problem comes up, mostly because of the air ingress. This is a major fabricated structure, so you have to see that air ingress somehow we have to overcome. Next slide. So these are the or the reasons besides what air ingress. The higher ingress in the mentioned the first line, the condenser tube choking due to scaling, high level in condenser hot well. That will also lead to, because it will lead to lesser cooling area, and then inadequate CW flow, poor duration of the uh, poor right? All and main problem you go to Next slide, please. Am I audible? Yes. Okay, so this is the water fill test. People aware involved in the maintenance side and the erection side, they must be aware of this test. We uh, we fill DM water up to the level of 1 meter above the tube nest level, or in some of the machines it is up to the blade tip level. So we fill the water and check for around 24 hours. There should not be any difference in level. So level should not go down. And we go stepwise up to this level so that any leakages in the lower level can be attended. Then we proceed further. So after this water fill test, next slide. There are the portions which are not covered by the uh, water fill test. So to cover that, either you need to do steam precision test, or during operation you have to do helium leak detection test. Right, so steam pressure test is after filling the water till the blade tip level, LP blade tip level, or the 1 meter above the tube nest level. The rest of the area, saturated steam is given to into that area, and wherever you see the steam coming out, uh, uh, you have to attend to that. So leakages are attended like that. Right. Next slide. This is a scheme. You people can refer to that later on. Not an issue. Next slide. You need to actually provide a saturated steam for steam pressurization. Right. So first it will actually heat up the top layer of the water. Then it will start to form. The steam will get filled up in the rest of the area. Next slide. So one of the problem is governing system problem. As you are aware, in a 500 megawatt machine, it is a not exactly a high pressure, semi high pressure, I will say, because it is operating at 8 bar pressure and 32 bar pressure. Most of the governing assemblies, they are operating at 8 bar pressure, and only that 32 bar oil is required for control valve, for operating the control valve. The higher is the pressure, you see, the higher is the pressure, the smaller will be the size of the servo motor. In case of in 250 megawatt machine where high pressure governing system is provided, the size of the servo motor gets reduced. Right. So one of the issues what we have seen is interconnection of the oil connection in a main trip wall. In the main trip wall there is a connection of a trip oil pressure and an auxiliary trip oil pressure, and after many attempts, we came to know that this connection has got interchanged. So you should not actually during the erection consider that these connections are sacrosanct, and probably there cannot be any problem in that. There can be some problem during the erection itself, time itself, because of hurry to achieve some of the milestone. These problems are ignored, and when actually you are operating the devices, then only you come to know that these sort of problems also take place. Right. So this was a very small problem. Only interconnection of this, the only connection of this auxiliary trip oil and trip oil pressure that got interchanged, and because of that, we were not able to operate the main trim valve properly. Right. One of the main problem was this, and the other problem is was the overspeed trip testing device. There, the problem was that for carrying out the uh, overspeed test during the running condition, it is not the actual overspeed test. To check the overspeed trip device, you actually bypass the draining of the auxiliary trip oil, right? So first you bypass the auxiliary trip oil, and for that you press one lever, and after that you start generating the test oil, and till that the pulse get operated, or speed valve pulse get operated. Just a minute. Right. So whenever this OSP trip testing was done, at that time, auxiliary trip oil was actually it was getting drained after conduction of the test. Then we came to know that you have to ensure after carrying out the test that after you have to ensure that this oil gets you see the pressure of that auxiliary tip oil, is getting generated. Only after that you have to restore the system, right? Otherwise it will actually trip the machine. The auxiliary trip oil will get drained, and it will lead to tripping of the main tip device, or draining of the tip oil, and tripping of the main tip device. So you have to ensure that. Although these are very small things, but when you are actually handling the governing system at that time, these small things may lead to actual tripping of the machine, which is actually not desirable. Right. Next. This is a picture of a O-speed tip test device, and you must be knowing about the O-speed trip release device, which is mounted in the pedestal number 1, right? Next. These are some of the common problems which normally goes away during the maintenance. Many issues come up because contaminated oil, which may lead to abrupt closure of the stop or control valve during operation, or hunting of the IP control valve, or even HP control valve also, and hunting of ESC. We have seen this is very common problem in the proportional valves. It was coming up very regularly, and it was suggested that oil should be properly checked, and there should not be any contamination in the oil, and proper cleanliness of the oil should be ensured. So these are the common problems which happen because of the oil contamination, or the purity of the oil is not proper, or the moisture level in the oil is high on the higher side. Because of this, the problem can occur on these in these governing assemblies. Right. Next. So high vibration problems. Most of you must have seen this high vibration problem, and the reason for that can be because of the imbalance, which is the main thing, because of the rubbing inside, because the turbine has got a very lower internal clearances. Because of breach of those clearances or rubbing of those internal parts, it can lead to actually it will reflect into vibration. And I will say that vibration is actually is not a problem itself. It is reflection of some problem. So there is some problem somewhere else which will get reflected uh, like a vibration, right? Either it will be because of the rubbing inside the turbine, or lesser clearances somewhere, or some assembly problem in the bearing or somewhere. So that will get reflected into the vibration. So all the reasons I have actually tried to collate them here. I'm not actually explaining each of the issues, but the reflection will be in the vibration. You have to see by analyzing the vibrations in the control TG rotor system, analyzing the vibrations, then you can actually conclude what sort of vibration these are. right? So all these can be the reasons for a vibration, reflection of vibration. Next, one of the reason is the resonance. In many of the recent times we have seen that because of uh, resonance in the support system and the rotating components, the natural frequency of that rotating components gets excited, or the rigid component also gets excited. Because of that, it will reflect in very high vibration. Sudden rise in vibration can take place. So we have to ensure that no components falls in between the operating frequency of the rotor. And you must also be knowing that some of the natural frequency of some of the rotors lies in between the operating during the run up of or coasting down. Some critical frequencies come in between the run up or coast down. So we have to uniformly or pass those frequencies or those speed. We should not actually stop at that particular speed, because stopping at that speed may lead to damage because of the resonance, right? The next, so these are the main issues which we regularly see, and we get a feedback from various customers. Any questions? You can.
Thank you very much,
please go
sir,
on.
for your nice presentation. It was a detailed investigative analysis on the key problems like bearing gear jamming, low vacuum, condenser low vacuum problem, as well as governing system issues. Now, if the participants are having any queries, please raise your questions. The presenter is ready for answering your questions, as well as our experts are available. Any questions? Mike.
Is there any question? Actually, I'm not able to hear. हाँ, ऑयल मैंने आपको वही बताया. एक्चुअली क्या है ना, ऑयल इंजेक्शन टेस्ट जब हम कर रहे हैं, एट द एंड यू हैव टू इंश्योर दैट इट इज रीसेट प्रॉपरली, राइट? हाँ, अगर वो रीसेट प्रॉपर, अगर रीसेट नहीं होगा, इन दैट केस ऑक्सिलरी टिप ऑयल विल गेट ड्रेन्ड.
Thank you, sir. Thank you very much. And next, we will be proceeding for this next presentations, which will
Thank
be
you.
delivered by
Thank you all.
NTPC Korba presentation. NTPC Korba presentation, and Ms. P.S. Nanda, Senior Manager, Turbine Maintenance, and Mr. R. Sridhar, Senior Manager, Turbine Maintenance, will be jointly presenting the case studies. Okay, Ms. Nanda is having more than 12 years of experience in turbine maintenance, and Mr. R. Sridhar is having more than 15 years of experience in turbine maintenance. On behalf of you, I welcome them to present these case studies. Thank
you. A very good afternoon to all of you. इसका कंट्रोल यहाँ पे हाथ में आ सकता है क्या? No, I don't have anything. चलो आप ढूंढते रहना, मेरे को फर्स्ट स्लाइड दिखा दो. इधर नहीं है सर कुछ. Okay. Not for changing slide. चलो कोई बात नहीं, आगे बढ़ा दो. So there were some case studies that have happened in Korba, and there was one particularly interesting incident that had happened during my tenure in Unchahar also. So we'll be discussing all that. The first slide, please. During the overhauling of our 500 megawatt version 1 machine. Version 1 machine contains 4 control valves, 4 stop valves for HP and IP both. And in both the cases, one in 2022 and just one more a month back, in both the cases, we saw that there were HP turbine cracks in once in inner casing. One more. Once one in the inner casing and one we found in the outer casing also. So this is the inner casing one, both in old versions. You see, this is the eye seal ring seating portion, and over there itself, these are those ventilating holes, and we found a lateral and a longitudinal crack, which was around 150 mm, not exactly 150, 125 mm in length. The interesting part was that just behind this thing, there was prior welding already done in this area. So it was thought that this module, whenever it was assembled, this module was brought from Farakka. It was a refurbished module, which was already installed in the previous overhauling. So then we saw that, and the one more thing is that there was no abnormality in our operation parameters. We had not got any complaints of vibration or any eye seal ring leakage, HP exhaust temperature high, nothing. When we saw the comparison between the parent metal and the weld metal, when we compared the weld metal, the previous weld metal and the parent metal, we found that the parent metal was actually bayanite, which is the original P11 composition. Involved our RLA agency to do replica on this welding materials, and we found that there were micro cracks present. Then we spoke to BHL Bhopal, and using their welding procedure, it was nothing. They said that we could do it on site only. And at that time, Eco Projects was doing the capital overhauling. So they only carried out the welding. We removed the entire weld material, previous weld material. We used, so next slide, sir. Yeah, we used fresh welding we had done, and we cooled it at normal air cooling. No stress relieving was done. And then we did DP, and we had replica, and there were no more microstructures present. So this happened last year. And this year, during our capital overhauling of another unit, same type, version 1. Version 1 machine, we saw that there was again HP. Sir, next slide, please. Version 1 machine, we saw that there was crack again, but this time in the outer casing. Now there's another station in Ramagundam which has also faced such problems in the outer casing, the barrel of the HP turbine. So see, these cracks these are 4 inlet pipes are there in the version 1 machine, and 3 out of 4 inlet pipes had around 150 mm and 40 mm depth cracks. And that was found through DP. We did DP testing of all the inlet pipes, of all the inlet inserts, of all the nozzle boxes. And then we had gone through extensive, repair because this was inlet pipe. The area of that cross section is around 125 mm. So we had to preheat before welding. Then we went for stress relieving, then air cooling. Next slide, sir. So this entire work was completed in, I think, 4 or 5 days. We immediately deployed evac alloys. They came over, they brought over their special electrodes, and welding, first grinding was carried out. After grinding, again, we carried out UT and DP. UT showed that there was some more weld cracks present. So again, we carried out grinding. This process was done repeatedly till we ensured that there were no more cracks left. Once we ensured that there were no more cracks left, then we proceeded for welding of the joint. After welding, we did SR. After SR, we carried out post-weld heat treatment and post-weld NDT for UT and hardness check. And then finally, we boxed up the machine. Next slide, please. These are the 4 things, sir. That is, the last one is after welding of all the cracks. And this particular thing, this second picture, where it was shown that once this grinding was done, again, we did UT. And finally, we went for welding. Next one, sir. Next slide, sir. This was the interesting thing that I spoke about. So in Unchahar, it happened twice that the unit tripped on overspeed test. During oil injection, everything was fine. But after that, when the unit started running, then suddenly it tripped twice. Once we reset it manually, we pulled the bolt. Second time, it didn't happen. So then we opened the pedestal. And there's one thing that we did not see at that time. When during the running condition, the trend showed that the test oil pressure was in a raised around 0.8. So no one, 0.8, what is it? No one bothers about it. Then when we opened the pedestal, first we saw that there was very little gap. As per design, it should be 1.5 between the striker and the bolt. But over here, we got around 0.7. That too, the grub screw, which was holding the bolt with the shaft, that had come out. So, and one more thing, there are 8 continuous vents present for each, 4 for each bolt. So basically, MOP ke bearings se jo bhi leakage oil hota hai, that has to, that travels through this test oil shaft. And then it gets, vented out through these vents. But because these vents were choked, 7 out of 8 vents were choked. So the pressure continued to build, and then it operated the bolts by itself. Now, next slide, sir. So this is what was suspected, that this, because of the choking of these vents, this thing was carried out. So what did we learn out of it? We learned that from next time on, there should be some alarm or some kind of an indication that the test oil pressure is increasing. The design clearance, that is 1.5, it has to be maintained at all costs. And the second thing is that this grub screw that we use for holding the striker in its place, that should be ensured that that is not protruding above the shaft. And the continuous vents have to be checked. Next slide, sir. Next. This is a new endeavor that has been carried out at NTPC Korba. The TDBFPs and the MDBFPs in NTPC Korba are of a different make. That is it's the only model in India that's DeLaval Stork made. So DeLaval Stork is a Netherlands-based company, and now it is obsolete, as are their spares. So there's this overspeed trip device of the TDBFP. This is also obsolete. Now, in our, we have 3 such units. So 9 such BFPs and 6 such TDBFPs. So this device was obsolete, and we didn't have any spare. Siemens was asked for the spare, and they said that we will have to develop a new spare, which will cost you 23 lakhs. So then we started thinking about other alternatives, and we contacted Triveni. And they said that, okay, we will do it. and they modified the test bed, the entire jig. And we sent 4 of our devices. And the pertinent thing to mention over here is that we could not carry out overspeed testing of our TDVFPs just because of this thing. And that's a technical non-compliance. So we sent 4 of our devices, and in presence of Sridhar sir, actually, he was the pioneer of this project. He made sure he stood over there, and in front of him, the test was conducted. And now we got back the calibrated thing. We installed it in our turbines, and it is working. 4 such devices, we got them calibrated at 9 lakhs, if I'm not wrong. And we would have incurred an expenditure of 92 lakhs if we would have brought from Siemens. So next slide, sir. This was one interesting case study.
This Triveni Engineering is also pioneer in turbine components. Unfortunately, we have a contacted, and this overspeed, because in our as per our LMIs, every year, every 2 years, we have to carry out the actual overspeed test, and we are not able to do the test from last, I think, 6 to 7 years, and this is big non-compliance for the. And we did this with lesser cost. And next slide. This another project is taken in NTPC Korba.
There's this movie, if you can play it, na? Ugly slide. That I think is a video actually. Next one.
Next slide.
Another one.
So this is regarding the on-site refining work at site, because nowadays the BHL has given, if you take the module, transportation, logistics and everything, it will take almost 2 to 3 months for every module. If you take the BHL, it will take minimum 10 days, and it's cost about 10 lakhs invariably. So we taken the model in 2017 HPT module, we successfully carried, and similar recently we did this IPT module. HPT module 2007 we successfully carried and we did the job, and that mission is running fine. Regarding IP, we taken the interstage fins. Interstage fins, one vendor, when vendor is there, and we have followed all the protocols. And on-site refining for the balancing area, interstage fins, and segments and rotor fins, everything we changed. And special jigs and fixtures manufactured at site, and we carried it. And by considering here, interesting part is that IPT casing has a lot of ovality. Sometimes it is about 1.5 and 2 mm also, because of high HRS temperatures. New missions, older version 1 missions, no problem, because 520 degrees centigrade, 540 degrees centigrade, higher ovality problem is there. And by considering all these ovality values and parting plane gap also, we calculated the fin height. Next slide, please. And we calculated the fin height, and refining. Refining work is normally they will do as per their procedure, putting the caulking wire and pull test and everything they will do. And theoretical part and technical part is that considering the ovality value, and we have to calculate the fin height. So we are taken up with that one, and we did successfully, and the module is boxed up and ready for on the opportunity, because this is a pooled spare and we can send to other project also. Rotor fins also changed. Yes. Rotor fins also changed. All interstage fins and gland fins.
For HP, actually, you can carry out the roll check, bump check because of the jigs that are
Jigs
already
are
present.
available.
For IP, you cannot do that. So no, the agency that we contacted, they brought their own special
fixtures and they did it. Yes. Newmac.
HP का किया था Swan turbines. IP का Newmac, and now we will be having our same 210 megawatt unit का एक होगा.
एक मॉड्यूल अवेलेबल है हमारे पास.
हाँ, grouting करना पड़ा. इसका अभी जब यूनिट ओवरहॉलिंग होगी, we will carry out the roll pump check.
Roll check on the एक बार हो जाएगा. Interesting part is that here the pull test is very, very important, because Pins height, there is a calculation sheet is there on basic of ovality, how much ovality is there. In Excel sheet, we can put it in Excel sheet, and there is standard format is there. थोड़ा सा apply करना पड़ेगा, considering the rolling diameter. Take the rolling diameter and you can calculate it. And because nowadays the most of the vibrations are coming due to yes. Coming to this, what you said is on the interstage field clearances, and NTPC has developed the new modified method based on the interstage fins, because interstage fins version 3 missions having 1.2 clearances, both left hand, but older version missions 0.7 clearance is there. When you are doing roll check and roll check, we will do only glance say 0.6 clearances. So whatever the interstage fields clearance, we don't know, because of steam wall, so vibrations are coming into picture. To nullify that one, sir is already discussed in the morning that revised centering method is brought into picture. So in extension that we have a 3 components. One is the rotor, and is inner casing, and top gland and bottom gland. You make it straight. That's all. So already somebody is asked that one regarding gland bush. We have to normally in a site, we have to take what spare gland, we have to purchase it and ask them either. So many parties are available in Haridwar. Oversize finning ready करके रखना है हमारे पास. Then based on the requirement, you have to machine it, offset machine at our workshop. So these are the basic funda. So because to maintain the clearances at the center, so steam will be nullified and vibrations will be come down. So after revised centering method, most of the NTPC stations having no vibrations. One is in extension that one is revised centering method, one is coupling phase corrections. So most of the OEMs are reluctant to touch the coupling phase corrections. So most of the OEMs, what they will say, let us say coupling phase is having a facial runout of 0.2. It's well and good. They will say, and don't do it. But when you take in connection opposite phase, when we have a HP rear and IP front, what is the resultant coupling phase runout? If it is more than 0.2, reject it. Recently, just 26th, we rolled the mission. All the vibrations are came down to pedestal vibrations are 1 digit, 7, 8, 9, and shaft vibrations are less than 100. Maximum is 70. In that mission, we seen that HP rear coupling phase is 0.2 and IP front is also less than 0.2. When you couple it, it is coming 0.3 and we have a contractor and he's directly he told that no, it's not required, but we kept the mission for 2 days, do it. उसको दोनों resultant में 0.2 का अंदर में लेके आया था. Earlier it is about 120, now it is less than 70. All CRO values are less than 0.2. We did the coupling phase correction in the IP front as well as nothing, no change. If it is changed, what will happen? We have again reaming horning is required, not reaming horning is required. Same position. No. So normally what the mission says that when you send it to any for refurbishment for IP rotor, put it in scope, phase correction. Otherwise, made it flat. So normally we will send to Bhopal. What they will do? They will check the 0.2. No, made a cut. So what will happen? It comes in a straight portion. So when we are coupling the 2 rotors, it should be coupling. So next advanced level is single rotor coupling phase is 0.2. When you couple it to opposite phases, it should be less than 0.2. This is the next advancement level. So in that case, there are many methods are there. Nothing. Manual correction, we put a small 6D wala bhi kar sakta hai, but that system is not proven because their method itself, they don't have a base part. Because what will happen, a resultant nahi milta hai. We have an Excel sheet, put on a stand. Nahi rakha. Actually, already I will share you separately. Resultant dekhna hai sir. Resultant less than should be 0.2. So Vasar is asking about this flatness. How can you check? Put on a simple stand and put a small 4 dials and you check it. What is the result? Resultant Excel sheet में आता है. But when you are cutting, be careful. It should not be फर्स्ट स्क्रैपर से हल्का कटिंग करना है, ऐसा कटिंग करना है, ज्यादा नहीं कटिंग करना है. So what I mean that when you are coupling the two rotors, both should be flat. In Simandri, in 2013, LP rotor having a taper of 0.4. We cut the rotor of IP rotor to 0.4 and made coupled. Again, vibration comes into 225 vibration again. Later, next shutdown, after 6 years, we made it flat and everything is straight, because when a unit is running at higher temperatures, it will be slide. Okay, it should be flatness. That is one of the part regarding the assembly. Next one, next slide, please.
रोटर का रनआउट हमने 0 देखा था, फ्री रनआउट नहीं देखा.
हाँ, फिक्सर एक स्पेशल फिक्सर बनाया, उसको पतला अराउंड 25 mm का एक बनाया था, उसमें स्टब शाफ्ट है, उसमें रनआउट 0.2 के अंदर में लेके आ गया. यस यस, लेके आता है. प्रीवियस स्लाइड, उसको फ्लैटनेस भी चेक किया था, जो फेस बनाया था उसका फ्लैटनेस भी चेक करवाया. पिछले साइड
आप किसकी बात कर रहे हैं सर?
फिक्सर, जो फिक्सर का जो
कपलिंग फेस के लिए ना, कौन सा है ये वाला? आई थिंक जो केसिंग था, केसिंग के लिए, जो केसिंग क्या 0.2 क्या 0.0 में था एक्चुअली.
उसमें देयर इज एन एडजस्टमेंट एट द बॉटम.
This was actually brought by the agency itself, checked by us at site, and then only we started after.
No, everything Newmac agency बनाया था.
Basically ये spindle का runout हमने check किया था.
They have a credentials. I think they did in like state board power plant or the same. Mahajan को काफी किया था. Exactly. UP Power also they did this job. Next slide, please.
This is a pull test being carried.
Next slide. This one is regarding replacement FR of fire resistant fluid. Regarding the slide, replacement is not the solution, just we put it because when I was in Simadri, the acidity level is 0.45. And we have a OS also, Natra is there. And we made a project that is using of resin, resin है, Thermax का resin use करके उसको हम लोग 0.08 तक लेके आया था. When I came in Korba, and we seen that here also acidity level is 0.45, and we started experiment with same resin with Thermax. That is very lesser cost. But in the existing system, we don't have a dry filter. In control feed system, there is a dry filter, forward and fine filter. Because of lack of dry filter, we replaced the many times the resin, but we acidity, because the moisture will gone to up to. Meanwhile, earlier PO is raised for replacement of the FRF oil, because replacement of FRF is not the solution. Once I am repeating, because in Kodankonam also lube oil system itself FRF oil. 1000 megawatt nuclear power plant lube oil system is FRF oil. So when it is acidity increasing, replacement is not the solution. Because why we are concentrated here, Indian Oil, IOCL, indigenous, they are supplying the oil with 850 rupees. This Solaris, Suprasta is supplying the oil about 2200 rupees. Okay. Suprasta, FRF, synthetic oil, EHCN, Solaris, EHCN. So with 50% cost, we got it, and our plant is about 40 years old. Then we thought that replacing the oil, most immediate solution. Nowadays, like for lot of parties are, which one is Minimac? Minimac is with 66 lakhs. They are putting a contract. We put up a 6 lakh contract. They will reduce the acidity up to 0.2, 0.3. Yes. Minimac and many of them is. And this is not the solution for replacement of the FRF complete oil. And our 3 units are having higher acidity, but 2 units we replaced because of lesser cost. Another unit we are doing an experiment with that resin based system.
Now we are planning to change it. Now that we'll get a vacuum dehydration, no, we'll change it from weak base to strong base.
Strong base.
Because more, what.
Yes, strong base.
First, already in practice.
We are in practice. Talcher practice mein, Dadri mein practice mein, all plants are succeeded. Exactly. Up to 0.2,
0.4 बहुत
0.4
ज़्यादा है,
and sir, up to 0.2 weak base we can use it.
हाँ.
Less than 0.2 we can strong base. Yes,
हाँ, इसीलिए
we
ये
don't have a
we
dry
waiting
hydration
for,
machine, है ना? We are waiting for dry and elevated. We are
Yes,
waiting
yes.
for this. Many plants are succeeded. Yes. Nitrogen plant.
आपका nitrogen capping is also.
Yes, yes. Exactly.
Resin डाल के हमने भी किया सर, weak base and resin हमने डाला है, but with that there are two problems. एक तो moisture बढ़ जाता है, and secondly आपका
अच्छा अच्छा. Okay, okay. Definitely.
सर हमारा 0.4 है, आपका 0.08 था.
Okay, okay.
Actually 0.4 is so alarming, no?
Okay.
Actually जैसे जैसे moisture will increase, your tan will also increase. Anyway, thank you. Sir,
No,
it
sir.
is like who came first, egg or
Sir, as
यही
tan
है.
value increases due to moisture.
Moisture, हाँ.
That's
If you
But-
can, if you can arrest the moisture, then tan will automatically.
automatically reduces.
And ये जो vacuum भी है.
Yes, yes. Now this may. Yes, yes. We are waiting
नहीं,
for
वो
that
वाला
mission,
सर
sir.
अच्छा idea है,
वो
वो
अच्छा idea.
adjuvant vacuum
Many
vacuum.
CPAT, our CPAT and Simadri, everybody is using. Yes, yes.
There are some
Implemented,
places जहाँ पे
implemented.
IS जो instrument LP blanketing करते हैं.
Blanketing.
Hello.
Next slide.
Hello.
Sir, any queries?
questions?
Question? Sir, regarding this over speed trip release revised, yesterday we, I think sir is in continuation with that one. Over speed testing unit. Yesterday we faced the one problem. One trip device was reset. Was actually unit was boiler light up is happened, and unit was rolled up to 3000 RPM. And in oil injection testing through ATT, the C&I is found that one bolt was reset, another bolt was not reset. What is an observation is that what is an observation is that when startup oil is generating, bolt was resetting. When we are going further for opening the stop valve, automatically tripping is happening. And we received a call at 8 o'clock. I went there. Many people are waiting. Okay, what I do? C&I is saying that your fly bolt came out and it is hitting. ओके उनका सेटिस्फाई करने के लिए मैं पेडस्टल ओपन करके चेक किया था, हाथ से चेक किया था, and barring gear it was okay. And later we analyzed in 15 minutes. There is a 14 mm gap is there. What is happening when I am raising the speeder? I am raising the starting device. Reset oil, startup oil is getting drained, and automatically it is coming back. Nothing but auxiliary trip oil is draining. Auxiliary trip oil is not holding at that point. No, barrel. Liter is 900 rupees. Okay, sir. Who is 900 rupees?
900 rupees per liter.
900 rupees. Okay. So we found that one bolt is having a travel of 16 mm, 14 mm. Another one is having a 12 mm. We corrected it by adjusting the screw latching. Automatically auxiliary trip oil was pulled and mission was immediately rolled. After unity, after 45 days overall, what we observed that during the overall, during the checking of maintaining the fly bolt gap of 1.5 mm, they pulled it back. So that 14 mm gap was not checked. And we found that it is 12 mm, we made 14 mm and mission was rolled again. Welding कर देता है तो उसका अटैक नहीं लॉकिंग है ना, उसमें देयर इज ए यूनियन जॉइंट है, मेक इट लूज, टर्न बकल है, उसको लूज करके एडजस्ट करके टाइट कर देते हैं.
एडजस्टिंग स्क्रू से आप एक
लॉक नट टाइट करने से हो जाता है उसका. ओके Sir, there are n number of problems here in oversplit device, sir. Many, exactly. Many things may be happen. Yes, yes. Every monthly we will do it, sir. Every month we will do it. This oil injection test.
सर वो कंट्रोल फिल्टर आपको बताया था 800 रुपए ना कंटूरा में 2000 का रेट है
कंटूरा अदर वही है ना
इसको हमने 800 में वो 25 किया
हाँ हाँ
उसको 800 में लेके आके 25 किया
Okay.
वहां से इंपोर्ट करके लाके
अच्छा
हमको
अच्छा
वो
नहीं this is a we got an approval through Make in India program because IOCL is a regular supplier to NTPC. This is IOCL program.
IOCL का 25 साल का लाइफ हुआ नहीं है उसका लाइफ क्या है
No, already in NTPC
In Unchahar, we have already used it. That happened in
through BHEL.
BHEL हमने अप्रूवल दिया है मगर क्या है उसका लाइफ अभी तक अनसर्टेनिटी लाइफ के ऊपर कितना साल काम करेगा IOCL में कोई ये नहीं है
No, but justification they have a research. I think they have their own research center, and recently they told that wonder is came that because of nuclear this war, Ukraine war, many European countries have stopped manufacturing this EHC and oil. Many queries are
cost of barrels have also
increased. No, 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 no. Complete replacement. Complete replacement. We cannot top it.
EHC को भी EHCM से आप नहीं कर सकते.
Yes. Any questions regarding this one or any other?
0.08 is it? 0.08. Okay. Yes, sir. Any other questions?
Any other questions? Sir, one more thing I want to share you, sir. One more thing, sir. When you are going for any overalls, we need to maintain the minimum critical space. So we recently faced the, not faced the problem. We are well reacted and we purchased the like UCL rings. Normally turbine component, very few components will be replaced. One is gland bush, another one unmachined UCL rings. You have to make it ready. Another one is gland sealing strips. Sealing strips, many vendors are supplying other than BHL also. Sealing strips, caulking wire and UCL rings and undersized bearing. If any rotor is there, undersized rotor is there, undersized bearing has to be procured. Otherwise, overalls can get delayed. Okay, thank you.
Thank you very much, sir, for your wonderful presentations. And your case studies are very interesting. And you have also brought these indigenous solutions in a very cost-effective manner. And it has given a lot of discussions among these participants also. And with this, we will have a tea break for 10 minutes. You can go back and you can assemble after 10 minutes. And at the reception, you are having this feedback form. Kindly take this feedback form and you can fill it during the session and you can submit it before you leaving this session. Okay, well, thank you, sir.
इधर नहीं है सर ये वाला नहीं है कहाँ था सर अब तांता बोल रहा है
मैं आया
ना ना सर
क्या किसको दिया था मैडम
चलिए इसका भी
कोई बात नहीं, ठीक है।
नीचे
अपन चलेगा सर।
ये नेहा है।
अच्छा नहीं।
हाँ जी, नहीं नहीं, मैं तो डाउन ही
इधर आ जाइए, चलो बीच में।
request all the participants to assemble back in the auditorium for the subsequent sessions. We will have two more sessions, one from Simaburi Energy, JPL, and another one is from Siemens presentation. Siemens will not come. Okay. Achha. Achha. Yes, sir. The next session is from Jindal Power Limited Simaburi Energy, which will be presented by Mr. Raghunath, Deputy Manager, who is having a vast experience of around more than 13 years in the field of turbine maintenance. So I request him to present this presentation. Please, sir.
Good evening to one and all. I just explained the presentation regarding, I am from Simapuri Energy Limited, Raghunath Vandanapu. I am having 13 years of experience in thermal power sector, turbine area. This project mainly concern of the revival of turbines. Actually, we installed a 150 megawatt Chinese unit, that is AN 150 13.2 model. This is basically from the unit is shut down from last since 5 years. After that, purchasing Jindal, it will be revival to get it generation. So that I can explain the problems which we are facing during the revival. Okay, that means it will be helpful. Maybe such type of issues, some of the issues covered in this slides. Some brief introduction is there, and I can explain the problems which are earlier revivaling time. During the revival, what are the problems we are facing, and after revivaling, what are the issues we are facing the issues. That is also I can explain that one. This is the last COD will be happened in 2012. After that 5 years it will be stopped, and there is no preservation at all the units in all the components. After that, we are taking over the Jindal at June 2022. After that, we have to take out all the things and make it ready up to July 23. By our chairman sir, we are targeting that all the 4 units will be generated before the July. By taking this target, we are move forward. These are the problems we are facing. I can explain one by one, slide by slide, actually. Main critical problem we observed is the HP casing, 8-stage diaphragm and 9-stage diaphragms are completely broken condition, which is having the broken condition, which is not revivable condition. So that what is the problem before that, how it will be happened is, during operation time, the HP casing heating line, which was helpful to casing for initially, that line was MOC is different. That line was bursted during running condition. So that after burst the line, there is no, we can't stop the unit immediately. So after draining the entire steam, it will be sucked into the vacuum, and cold air will be entered into the casing. This after cold air entering into casing, we didn't come down the unit into the turning air. Up to the turning air, it will be happened like that. After inspection, we found that this condition, this type of condition we observed. And each and every diaphragms we conduct the MPT test, and we found some cracks is also found. refining किया था साइड में, इन हाउस में किया था, उसको करके हमने इसको चलाया था इसको. And one more thing is unit one, all the 4 units we had revival all the 4 units. One of the unit we had the problem of rear bearing, HP rear bearing, that is HP rear bearing, and this was the generator side, generator front side bearing. The bearing which we are conducting the scraping and scraping blowhole was found in bearing actually, and this bearing HIP bearing due to the uncertainty of overloading, HIP bearing was rear bearing was failure. Both the corrected and rebuffing done, and we replaced the bearings also. After rebuffing, we found that. And this is the entire system which we instead of the plant was installed in the Bay of Bengal nearer to the sea. Corrosion problem is there. Most probably the entire system was corroded in the form of the pieces. This is the condenser structure and condenser piping conditions. And we have to more efforts will be done, and we can eliminate the piping, the seawater corrosion also by by making the inside lining of the pipeline. And also we applied the polyglass coatings inside the polyglass coating. Instead of PU coating, we apply the polyglass 1000, which is helpful to glass flake coating. And we reduce the size of the bolts also because of corrosion. It will be struck out, and removal is very difficult, so that we can change the bolt, GA bolt to, and diametrical clearances also reduce it to lesser size. After revivaling, we had this picture. These were the problem that PU coatings are that pipeline was PU coatings which are observed in PHEs also. Entire PHEs were choked by that PU coating wraps. In that way, we have changed the PU coating to this polyglass coating. Polyglass means glass flakes coating. And another thing, already our colleagues are explained, our friends are explained the moisture and tan values of the system. We are also in 4 units. After 5 years of revival, we didn't use any single barrel of oil for new top up or new refurbishment. All the oils were refurbished, and refurbished means oils are filtrated in-housely. By taking care of the filtration missions. We had 3 missions are purchased, and we hire the 4 missions of LVDH and also 10 removal missions. And recently we purchased total moisture removal TMR mission, which is providing N2 capping, nitrogen capping for the DH oil system. We had actually we had a 150 megawatt, means we had only 1000 liter of DH oil. Yes. That is a Frequel oil, fire resistance Frequel oil, which is also imported oil, at least almost cost of 2,800 rupees per liter. We entire oil we are refurbished, and the top up will not happen. And we that is we proudly say that the entire values are within limit. Nowadays also we maintain the tan value and NASH values within the range, and that is come down to 0.1 also we have maintained tan value. And MOT oils also we had external centrifuge. We purchased external centrifuge, and also LVDH missions. We maintain the values in proper way. It is PU coating removal and refixing applications, coating applications during application. And after start the unit, we faced one of the issues of bellow failures. Here LP having the LP piping, that is CRH and extractions having bellows installed in our unit. That is we didn't expect that the life of the bellows, and we didn't check that before that. After checking the bellows, we got the puncture in bellows, and one of the bellow had a minor pinholes is there. After running, it will be damaged condition. We replaced that bellow, and after that we had conduct the survey of all the expansion bellow joints, and we revival the units. One of the gearboxes in seashore area, we had the major issue of corrosion, and water ingestion, it will damages the bearing and gearboxes. So that we are and in that condition we have to operate the gearboxes that wear and tear will be happened. Entire gearbox we had refurbished the gearboxes and gears. Yeah, in local vendors we developed the gears and gearboxes and refurbished the gears. All the gearboxes and and we are operating valves which are refurbished for lesser time. This was the vacuum pump impeller. This is a acidic pitting is observed we had. Actually, vacuum pump, liquid ring vacuum pump, there is a zero clearance area is there. 5 years of stagnating the acidic water, it will happen like this type of problem will happen. We are taking the action, but we didn't have, in case we weld the material, welding or cutting will be happen, welding and glazing will be done. For balancing also required, but we didn't have that much time, so that we had applied the coating that has wear resistance putty. We apply the wear resistance putty of Duramar, and this will be as it will this putty help putty and application of this primer. Those are helpful for reduction of friction losses also. It is energy saving implementation also. It will prevent the pitting corrosions and also energy saving, so that we go for this this type of application, and we get the energy saving of 1.1 kilowatt also for each pump. Life presently we receive 5 years of warranty, sir. We inspect the pump after 1 year. Actually, it will take the 3 months back. We are applying this coating. They guaranteed for 5 years of running operation. Yes, sir. Yes, sir. At the tip also we maintain the clearance, like that the clearance, minimum clearance, we apply the coating. These are some examples of corrosion issues we are facing actually. One more issue is there. LP and HP heaters, we found the drag is there. That means we found the pressure difference is there, and drip control is also not maintained in previous time. So that we found, we want to know that what are the major issues there happened. So we can proceed for removing of entire tube bundle and inspect the shell and inspect all the tubes and proper scaling. We found that scaling is observed at the bottom of the scaling is observed at the surfaces of the heater, and also the face and some of choking is observed at emergency and normal drip lines also. So that we remove the entire tube bundle and clean the entire shell with pressure jetting and acid cleaning. After that, we had this. At this time, we had the good performance and terminal temperature, which is measured for heaters, that is getting impacted for efficiency also. We get the good heat rate and good efficiency of the heat rate and heat efficiency of the heater, heat exchanger. And one of the major issue was there HP bypass valve and mainstream stop valves, which we are going to refurbish. After refurbishment, one of the valve, this was HP bypass, we had to then after servicing, we had to go for calibration. During the calibration, what happened is there some of the person, C&I person, didn't know the actually commissioning and voltage regulation problem. Though that happened, the upper limit will not cut the valve. Actually, motor will operate the valve and go for until the upper limit. So that what happened, valve will be back seated, and this is the gate valve, high pressure gate valve. So the gate valve will disc will be dislocated from this. This will be the dislocated from this the position, and it will not go for that wedge area, and that dislocated disc will pressurize, push back to the pressure seal. So that valve will be jammed. But this how we can eliminate that? Only one of the probable reason is to remove the segmental seal. But segmental seal will be structured into the system, so that we have to glose the segmental seals of entire segmental seals. But segmental seals manufacture lead time will be the 6 months. So 5 to 6 months you have to wait for the segmental seal manufacturing. So how can we eliminate the problem? But we have to revolve the unit in emergency cases. So we first we have to proceed for entire segmental seals closing, and then we made the one drawing. We made one drawing and one piece of segmental seal and make it in our own workshop. That is fabricated from P22 pipe, which is segmental steels actually has in forged condition. Forging process it will be manufactured, but in pipe also forged condition. So we concluded that pipe is also the sufficient for making the segmental seals. That pipe will be P22, which is available for in our plant. So that we made the pipe to segmental seals in our own workshop. After that revivaling, it will be operated good condition. Still there is no issue at all. After shutdown also we can check the segmental seal condition. There is no issue at all, no expansion or uneven problems is there, not there. And it will be freely removable and valve will be good in operative condition. Another problem is there CW walls, which is CW walls is larger in size, 2200 diameter. So this refurbishment will be the very tough task to us. Why? Because we have to send the workshop. It will be transportation cost is more over the walls cost. Actually, that much, and this wall will not refurbished in the nearer area. We are plant location is Nellore, which is far away from Hyderabad or any Gujarat, Mumbai. So that we have decided change the seals. Made to develop the seal and change the seal. After that, we had applied the rubber coating. Rubber means PU. Like that ebonite coating, which is we are shown in ebonite coating. Like that, this rubber spray will be applied for that corrosive resistance. Yeah, those are the challenges we are faced during the before the startup of the unit. After startup of the unit, we had faced the two major issues. That is one, that is a high vibration issue in HP turbine bearings startup time. Why? Because this is a problem occurred during rolling. The improper inline steam issue, that is temperature issue. Casing expansions is not in proper way. Why? Because of happen. We are as per OEM manual. We don't know how it will be operated actually. So we have to follow the unit entire as per OEM manuals. For going to OEM manuals, we have to admit the steam of live steam. We have to go for the live steam parameters, which are MS or HRH parameters maintained above the 50 to 100 degrees with respect to the casing temperature. Before the unit startup, we have to initially heating the casing heating line. We have to heat the casing with the help of casing. 50 to 100 degrees. We are going to rolling 1000 RPM, but it will not happen and more vibration will occur, and we have to withdraw the unit. So we check the trends of all the parameters, and then we have to go for our team will be operation and maintenance team will discuss about this issue. We observed one thing. We have the measuring points of the main steam is before the inline of the valve. After governing system, pressure and temperatures are reduced. That pressure reduced that much reduced. We didn't that is 100 degrees. That maintaining temperature will certainly cools the IP turbine. Actually, IP and HP turbines. That means that is not sufficient to maintain 100 degrees temperature. So that we go for 150 degrees, 130 to 150 degrees temperature for a HP and both IP. Then we have to try for rolling. The system will be succeeded to successful rolling. After that, we didn't have any vibration issues. The unit will be stable and running in good condition. Meanwhile, we have to maintain the differential casing temperature with and also a differential temperatures also. Differential means the top bottom differential temperatures also we have to maintain while observing the live stream temperatures. We are getting into the live stream temperatures. And one more unit having HP LP turbine bearing temperatures, bearing vibrations issues. We got second time this issue observed in after shutdown the unit. We have take the unit and reposition the unit, resynchronization, vibrations issue observed. How vibrations, these vibrations are issued, we check out all those conditions. We observed one of the drain lines are so subcritical units. We have to check all the drain lines because there is any condensation will impact, any condensation will be happen that will more impact at the turbine casing temperatures and all the issues. So we found that one of HP by HRH line HP bypass HP bypass, we didn't have any steam traps is there. Steam traps is not there, so that we provide the steam traps and one of the drain line choking, which is which will be newly which is dechoking will be conducted and taking the unit back and getting low vibration, no vibration at all. These are the plannings, and we conducted the UMPT, UPT bearing temperatures while we were revivaling of the units. Low balancing is conducted, and PMI check, positive material identification checks also conducted. For condenser, we have to conduct ED current test and a flood test also conducted. During ED current test, we got the tubes which are low probability of failure. That will be, we are plugging the tubes. Some of the initiatives we had taken for the testing of safety valves. That is, we fabricated the one of safety valve test bench. Normally, normally what happened when we have to service the safety valves for HP heaters, LP heaters, glass steam, and derators. We didn't have any testing purpose. We have to check as per previous readings, so that it will impact the blowdown or it will impact the system healthiness. So that we have to fabricated one table, that fabricated table, which can able to test all the safety valves which is related to the turbine auxiliaries. It will be cost reflection, and it will reduce the cost, and we need not to check any further Travi test. We didn't have to require. We check the wall and get it healthy. And one more issue is there for taking the unit back. Whenever unit startup is there, one startup oil pump is there for latching purpose. This startup oil pump having this is the positive displacement pump, but it will not require any priming issue. But we observed that pump requires some venting, so that venting will be conducted before that. The one of the gland portion seal housing plug will be removed for venting purpose. That will be unsafe, and it will takes time to get the pump will be pressurized. So that we provide the one of the line, and that will be modified. Sir. Sir? Yeah, yes, sir.
You are using water for safety valve.
Yes, sir. Yes, sir. Density difference is once water and steam density difference is only there, sir. That means we have to consider 0.1, 0.2 safety factor, sir. More than 1.2, you have to add the design pressure, sir. It will be sufficient for testing purpose. We are using feed water side, sir. HP heater or LP heaters, water will be there. From steam side, we have to only extraction pressure is there. no issue at all. For we had tested and installed all the walls, sir. Yeah, still no issue at all. We have to increase the 0.1, 0.2 into 0.2 for safety factor if you have to add. This vent line is provided for say this positive displacement pump of startup oil. It will reduce our time and consumption of fuel consumption in boiler area also, and we get the startup a very earlier before the startup. This was the earlier picture I told that segmental seal which is in-housely fabricated, that diagram. Yes, sir. After, but we have to finish it in workshop machining. The true value is 0 to the late parallaxis error which you have to get the machining. That is only the difference, sir. After that, if you require, you have to take the blue match also, sir. No issue. And we have to fabricated some pipes also due to because of lack of pipes. We just fabricated the pipes by rolling operation and fabricated the pipes and joined the install in a seawater system. One of the modification proposal energy saving is there. All the 4 units we didn't have any auxiliary steam separately. We have to conduct one survey and we had to conduct each and every unit with a PRDS, auxiliary PRDS with a live unit. If one of the unit is running condition, we can use that steam to another units light up or casing heating or auxiliary steam. We have to supply the steam to auxiliaries, all the auxiliaries. Oh, we made the plan for this one, and we have to. This project will be in implementation stage. After completion, it will save the unit nearly 4 to 5 hours of light up time, and it will around 20 kl oil will be saved for each unit of Semapuri Energy Limited. So that we take this opportunity. And one of the best is that after 5 years of revivaling, we didn't have any station PLF and all the parameters which is required, maintaining 92.5 and PLF also maintaining greater than 95%. And vacuum also 90 kPa we observed, and no major deviations in observed in all the units, all the 4 units of the turbine. Any questions is there? Thank you, sir.
Thank you very much, sir, for your nice presentation. It was covering the challenges, how the challenges have been transformed into the superb opportunities. You have not only revamped these systems and put into better serviceable conditions, but also brought excellent performance conducts. Excellent. Congratulations for the JPL Simaburi team. And with this, now we have come to this concluding part of this day-long workshop on turbine critical systems with critical problems, case studies, and solutions. And you have been listening to us for more than 6 hours, 6 to 7 hours, and this is a time to hear from you. So before concluding and offering vote of thanks, we would like to hear from your experiences about this workshop. Now I would like to request Mr. Tapan Rai sir to share his experiences about this workshop.
Namaste. It is respected Mitra Sahab, Katre Sahab, my dear colleagues, ladies and gentlemen. Today workshop turbine means ये हम लोग सब मित्र साहब भी सुबह बोले थे जे that is the triangle is the topmost position is the turbine. Boiler में कुछ होगा, auxiliaries में कुछ होगा, तो then it will be revivable. But in turbine में कुछ होगा, तो then it will be entire plant will be shut down. तो इसीलिए टर्बाइन में जो मेंटेनेंस एस्पेक्ट्स एंड मेंटेनेंस प्रोसीड्यूर है, that should be very carefully. Otherwise, एक बार मेंटेनेंस हो जाएगा, then again it will be a rework, should not be desirable. ये that is the all maintenance engineers का मोटो होना चाहिए, rework should not be there. ठीक है, नंबर 1. नंबर 2 है जो इच्छा है. मैं एक्चुअली सीमापुरी रिवाइवल में मैं था, सीमापुरी रिवाइवल में 6 मंथ में था. तो वो जो पिक्चर आप लोग देखे हैं तो उस पे तो ठीक है. और एक चीज जो हमने फेस किया था वहां पर, नाइदर एनी ड्राइंग्स, ओनली थिंग इज दैट ओनली मैनुअल वाज देयर. एक मैनुअल का भरोसा में इतना चारों यूनिट आपको रिवाइवल हो गया है, बिकॉज ऑफ दैट पीपल हैविंग वर्क विद देम द मशीन. इतना इच्छा शक्ति था. सुबह 9 बजे से रात 2, 2:30, 3 बजे से ये लोग काम करते. मैं बोलता था कभी भी घर गया 12 बजे गया तो फिर 1 बजे वो आके बोला जी हाँ ठीक है कर देते हैं. इवन हम लोग CW का जितना है लाइनर से अभी काम चला रहा हूँ. मैंने ऑल सरा हुआ ट्यूब्स था. बेंडिंग मशीन में हम लोग ट्यूब फैब्रिकेट किया, हाँ फैब्रिकेट करके उसका अंदर में लाइनर लगाया, मैनुअली लाइनर लगा के हम लोग उसमें काम किया. तो दिस इज द इच्छा शक्ति अगर है तो आप कुछ भी कर सकते हैं. दैट इज द मेन मोटो ऑफ एनी टर्बाइन इंजीनियर. हम लोग को जितना है KW टर्बाइन का बारे में एक्सपर्ट मिल जाता है, लेकिन बट चाइनीज यूनिट के बारे में एक्सपर्ट, ऐसे ही टर्बाइन के एक्सपर्ट कम मिलते हैं. फिर भी चाइनीज तो और भी दूर है, क्योंकि चाइनीज यूनिट इंडिया में इतना नहीं है. ओनली पब्लिक प्राइवेट सेक्टर में कुछ है. तो जो भी है दिस इज हम लोग जिप्ट का थ्रू से ये एक एक टॉपिक्स को हम पकड़े हैं. नेक्स्ट टॉपिक्स हम लोग को और भी टर्बाइन का मींस BFP TDBFP का ऑपरेशंस, TDBFP का फेलियर्स, जो भी अनदर ग्रे एरिया ऑफ ए पावर प्लांट, अनदर ग्रे एरिया फॉर TDBFP टर्बाइन एंड दैट गवर्निंग सिस्टम. तो ठीक है, मैं कटरे साहब एंड हम लोग के जोड़ी साहब जो लोग हैं सीनियर्स लोग हैं. हाँ, और एक मेरा जो है जी, हम लोग डिफरेंट जैसे मित्र साहब आया अदानी में, फिर सरकार साहब आए थे, तो हम लोग चाह रहा है जी वो भी मेंटेनेंस का जो प्रैक्टिस है कहीं पे बेंचमार्क करके, कभी अडानी में करेंगे, कभी DB पावर में करेंगे, और भी जितना पावर प्लांट है, सो दैट पीपल शुड इन्वॉल्व. यहाँ पर 4 आदमी आए, वहां पर जाके हो सकता है और भी कुछ लोगों का एक्सचेंज ऑफ जो वर्क्स का जो एक्सचेंज है, एक्सचेंज ऑफ आइडियाज का जो होगा वो, दैट विल बी, आई थिंक इट विल बी हेल्प ए लॉट. ठीक है, थैंक यू फॉर सक्सेस. ओके, थैंक यू.
So thank you very much for your encouraging motivational words. Now I request Mr. Hadi Abbas, AGM Turbine Maintenance, to share his views.
Respected seniors, मित्तल सर, काटरे सर, जौहरी सर तो है नहीं, रॉय सर, तो आज कुछ सीनियर लोग भी थे हमारे साथ और बहुत अच्छे सीखने के लिए मिला. खास करके रॉय सर का जो टरबाइन का, HP टरबाइन का मॉड्यूल के बारे में बताए थे, जो बहुत कम लोग इसके बारे में डिटेल्ड एक्सप्लेनेशन होता है नॉर्मली. तो एक तो मॉड्यूल का ओवरऑलिंग के टाइम में आपका जो सजेशंस थे सर, वो बहुत ही अच्छा काम आएंगे हमारे लिए. और उसके अलावा जो NTPC के जो सर लोग आए थे, मैडम आए थे, उन्होंने भी कुछ अच्छा बताए थे कि जो कंट्रोल फीड का हो गया, जो ओवर स्पीड ट्रिप डिवाइस के लिए है, बहुत अच्छा लर्निंग्स है हमारे लिए. और इसमें क्या है, इतने सारे पॉइंट्स में अगर एक भी इम्प्लीमेंटेशन में आ गया तो इट विल बी ह्यूज प्रॉफिट्स फॉर द कंपनी एंड खुद के लिए तो है ही है. ऐसे ट्रेनिंग्स होनी चाहिए. और थैंक जिप ऑन बिहाफ ऑफ DB पावर. और बहुत अच्छा लगा यहाँ पे आके पुराने लोगों से एक बार और मिलने का एक अपॉर्चुनिटी मिला. थैंक यू सर, और थैंक यू ऑल.
Thank you very much, sir. Now I request Mr. Samir Kumar Mitra, sir, to have few words.
Good evening. Thank you. Thank you for organizing such a wonderful workshop, or I should say, get together of the Turbine fraternity. And what I was thinking that what I have gained from this workshop, that what Mr. Tapan Rai was mentioning, Ichha Shakti. So he is the ideal example of Ichha Shakti. He started from condition monitoring. I know him from the very beginning of his career. And he वो जो बोला लगे रहो ना, लगे रहो टाइप का आदमी है. कुछ भी होता था, any time, any day, any time, anything happens, he is present. Anywhere, any problem or any issue or any new initiative was there. So I was astonishing how they have done this wonderful things, because I have done a few due diligence of few plants near about where, because then he was acquiring some plants. So like Yathena and other Amarkantak. But those plants were 100 times better condition than this plant they have acquired. So I was just wondering how they have, because had I been done the due diligence, I have immediately rejected that plant. It's impossible. So that they have, I think they have revived it from negative, not from zero. So that's a very challenging and this thing revival process was, because everything was broken down and it was near the sea. So due to salinity, everything has got corroded. So after that, they have done this. That's a wonderful thing. Another takeaway from this plant was that Nari Shakti, what I have seen here, because that lady in the Korba, NTPC Korba, she has the confidence in her the speaking was very much impressed, very much impressed me. I've told her I'm impressed, because I know that during turbine overhauling, how much pain you will have, people have to take. You'll have to stay there. Yes, he was mentioning you cannot leave it on these technicians. They will do as per their whims. You go for a sleep or rest, and they will do. Then your total 30 days work will be zero, because they will do some corrections as per their will, which you don't want. So staying there and working with them in odd hours, it's very much commendable job, and the experience she has gained is really applauding. So this is at the end, I should say that this is the beginning. We should hope that we start knowing each other and start exchanging ideas and our experiences, and especially the similar type of units what we are having in this area, like 600 megawatt and 600 megawatt in BHL units. So I think then only the actual gain of this workshop can be harvested. So I think everybody will have the others. Most of the people must be having, and they can have the others contacts and details of other people who are present here, and they can exchange their ideas and issues facing in their plant. Especially they can contact Tapan Roy. You can contact for any your queries, and I'll invite him during our overhauling, this rolling. So at the end, I should say that it's a wonderful endeavor by JIPT, and they are continuing. I know they have invited me several times, but due to some reason or that, I could not attend. But I have also gained a lot from this workshop, and hope others have also gained. Thank you.
Thank you very much for your kind words and greetings, sir. Once again, thank you very much on behalf of JPL. and JIPT. And with this, now I request our Director R.D. Katre to propose a vote of thanks.
थैंक यू सर। आज का दिन काफी अच्छा रहा। रियली काफी अच्छा लग रहा है कि हम सब लोग इतने लोग इकट्ठे हुए हैं और सिर्फ इकट्ठा नहीं हुए तो हम लोग एक काफी अच्छी चीजें सीखे हैं साथ में रह के। जैसे मुझे सब लोगों के इससे लगा कि हर चीज कुछ ना कुछ तो मिला कि जैसे practices of the Korba or practice of the JPL or practices of other plants. तो ये solutions कैसे उन्होंने किया तो definitely it will be helpful to us in our practical life. और जैसे सर ने बोला कि डेफिनेटली ये जो हमारा एंड्योर है उसको दिस इज लाइव बिकॉज ऑफ योर्स ओनली। कि जैसे शुरुआत तो ठीक है कि ये जिप्ट से शुरू हुआ, बट यदि और लोगों से सपोर्ट नहीं मिलता तो इट वाज नॉट पॉसिबल। इतना अच्छा लगता मुझे कि यहाँ हमारे TRN की टीम है, JSW से आते हैं, JSW झारसुगड़ा से, दे ऑलवेज पार्टिसिपेट किया सर, ऑलवेज पार्टिसिपेट। मुझे पता है कि दे आर नॉट दी IP पिच, बट उसके बावजूद भी वो आते हैं एंड दे ऑलवेज सपोर्ट टू अस। रियली आई एम थैंकफुल टू ऑल ऑफ यू। और इसी के साथ में हम लोग ऐसे ही प्रोग्राम्स करते जाएंगे। Definitely just there are two regular initiatives. We have this workshop as well as another is monthly online session on the innovation and new technologies. वो जो सेकंड जो है कि न्यू टेक्नोलॉजी एंड इनोवेशन जो है we always invite to some event person of that field. Just last month we have invited Dr. Sunil Kurma from Texas University, USA, on the topic of nuclear energy. And this month was on this artificial intelligence and machine learning in energy sector. It was from Manish Srivastav. Along with this, just sir ने बोला है कि we will form the groups or communities. Community for this just like electrical, turbine, boiler. कि हम लोग ऐसे ऐसे ग्रुप में हर प्लांट के जो लोग हैं वो एक दैट में बी व्हाट्सएप ग्रुप आल्सो, उसको भी हम लोग ये कर सकते हैं। और एक किसी टॉपिक पे हम लोग या कुछ प्रॉब्लम्स रहते हैं तो वी विल पोस्ट ऑन इट और वी विल डिस्कस ऑन इट एंड वी विल बी म्यूचुअली बेनिफिटेड विद दिस। तो ये वाला जो है सर हम लोग इसी महीने में शुरू करेंगे। देन जो है कि नेक्स्ट मंथ का हमारा जो टॉपिक रहेगा दैट विल बी अनाउंस्ड विथ आफ्टर डिस्कशन विथ ऑल ऑफ यू बाय द एंड ऑफ द फर्स्ट वीक ऑफ द सितंबर। और इसके साथ साथ में और मुझे आपसे सपोर्ट चाहिए था, हम लोगों को सपोर्ट चाहिए कि और हम लोग क्या कर सकते हैं। हम लोग डेफिनेटली विल नॉट गेट दिस ऑल दिस थिंग आंसर टुडे ओनली, बट हम लोग आगे आगे बढ़ते जाएंगे और हमको रास्ता दिखते जाएगा। तो रियली आई एम थैंकफुल टू ऑल ऑफ यू एंड इसके साथ में ही जो इससे हमारे प्रेजेंटर्स है हमारे जो एक वी हैव द लेगेसी दैट वी ऑफर टोकन ऑफ लव टू आवर प्रेजेंटर्स। वेरी रिक्वेस्ट करूंगा कि प्रेजेंटर्स को गिफ्ट देने के लिए मित्रा सर डैश पे आए, तपन राय सर, प्लीज डू कम सर। कार्तिकन
Sir, Hadi Abbas, sir. DB for all group. Yeah, please come. Sir. I request our chief guest to award a small gift as a token of our affection and love. Mr. Raghunath, Simubri Energy. अच्छा DB पर सर आप इधर ही आ जाइए. Some of you can join here so that अच्छा हो जाएगा. You can come here. 2-3 people. So हाँ center हो जाएगा. Mr. Raghunath from Simubri Energy. JSW also, sir. And participants from JSW Energy. Sir, आइएगा आप. Those are behind us. And participants from Adani Power. JPL. Satrughan Sahu. Sir, may I invite Mr. Satrughan Sahu, please come on dais, please. Yes. Yes, yes, please come. Mr. Satrughan Sahu. Thank you, sir.
थैंक यू वेरी मच टू ऑल. और आप सब लोगों के लिए कि आप जैसा है कि सर इसमें एक्चुअली हमारे जो स्टूडेंट्स हैं पीजीडीसी के वो लोग भी सम्मिलित हैं. एंड आई नो कि आप पे तो बहुत अत्याचार भी हुआ होगा आज. क्यों? हाँ
सुबह से
लगा हुआ कि बहुत चीजें जो है एकदम बड़े बड़े लोग जो सीख रहे हैं वो आज हम लोग हम लोग को बताया जा रहा है. रियली हाँ बट ये आप लोगों के लिए काफी अच्छा है. लाइफ लॉन्ग दैट विल बी द लर्निंग लेसन फॉर यू. काफी अच्छा चीज है कि वो आपके
जगह
काफी
में आके ज्वाइन किया है.
राइट हाँ.
दैट इज द गुड प्लेस. आप लोग जो ज्वाइन किया है अच्छे जगह में लर्निंग स्टेशन में ज्वाइन किए हैं. ठीक है।
और आपको हर बार ऐसी ही सब चीजें अच्छी मिलती जाएगी यहाँ। थैंक यू वेरी मच सर।
Please share the feedback form.
दुर्गे सर सिक्योरिटी वाले आ रहे हैं। हेलो।